got a USB stick?
Yes, we have USB connection.
Okay.
Or do you want to use your laptop for
No,
presentation?
I'm okay. I just transfer it across.
Oh, sweet. So, are you Jade?
Jonathan.
Oh, cool. So the second one?
Yeah, I think so.
Oh yeah, cool.
Oh, no, third one.
Third one.
Yeah.
Oh, all right, it's right. Oh,
Yeah. Yep.
Oh, you need a USB. Right?
Yeah. Cheers, thank you.
Is it XPS?
It is, yeah. It's a nice laptop.
I was gonna go for this one, but then I changed my mind to for Alienware.
To what?
Alienware is like heavy ass.
I really wanted one of them, or one of the Razer ones.
Oh yeah.
But it's my work laptop, and I was like, these sound too much like gaming laptops. They're
It's
never
too
going to
much.
approve that purchase.
But this is like super color accurate. Right? This one.
It's really nice. Yeah, I only went for the 1080p screen. You can get it at 4K one.
There's no need for 4K on a 15-inch laptop. Too much.
I'll just test it quickly, make sure my video is working.
Oh yeah, cool.
It should work.
So this one.
Yeah.
Yeah, as long as it's in the PowerPoint file, it's gonna work.
You have to click. Yeah.
Sweet.
Yeah. That looks great.
Cool.
Thank you.
Ready to go. Let's.
Do we have a mic as well? This mic. Yeah.
Yes, Mac, and there's a remote one. So
Oh,
you
yeah.
can just put it on.
I'll just use this one.
Yeah, cool.
Cheers. Thank you.
All good.
Do we have,
We still miss two presenters.
we're still missing two
Yeah.
presenters?
All files are already done.
Okay, so we've got,
No, this one.
this one,
I'm not, 1, 3.
okay, and who do you know who's presenting? It's okay,
For this one, it's
all right. John, and then for this one? Ted, who's in it, he's
Right.
Maybe,
It's a guy, right?
yeah, maybe it's, it depends sometimes then.
It's not using his own
This
laptop.
is true. Hold it. That was it, no reject? Or, yeah, that was probably. Okay.
So do you need a time finder for the?
What have you been doing?
It depends on the channel.
Yeah.
Some people, they just don't care, they don't track the time. Some people, they prefer to focus on the presentation, so I can just give them 15 minutes.
Okay. Yeah, just give them 15 minutes.
Yeah.
Give them a 5-minute warning. And then come in for the touch and move again. Probably in time to make good so far. So,
Yeah. We'll watch it like a little bit earlier. So.
yeah, even the big session this morning, I think we were about, what, 10 minutes. Well, that's good. Dinner was really nice last night.
Yeah, it is.
Did you go out afterwards or did you just go home?
Straight home.
Yeah, that was.
I was going to keep my eyes open. I don't know if it's because the alcohol or
Oh, it's a very. I mean, I find.
We're opening this.
Oh yeah, I just normally put on the desktop. Is that okay?
Yeah, sure.
Is this the
Yeah.
file?
First one.
Oh.
Can open it.
And are you presenting, Jeff?
Yes.
Yeah.
Go to the second.
Yep.
Do you have videos inside?
I'm sorry?
Do you have videos
No.
inside? Oh, right.
So what is he doing this? This is Susan's.
Yeah, it's yours. This is small enough for wherever you want to sit.
Website or whatever you like.
LinkedIn.
Quite well. So she, yeah. Oh, so how are things going this year?
That's pretty nice.
Yeah.
We so did the project with the only two other guys. Yeah, the count. Yeah, we did the project. We have like really short.
So this is your thesis project?
precision automating. They appreciate like the technology thing is always tricky to engineer work.
Yeah, oh, absolutely. I mean, especially on you know, this is the kicking.
But during testing, it was perfect. There's always a
It's very fun.
Hi everyone. I just want to check who we've got here from the different papers. The first paper is the effect of hints on user safety behavior in VR. Do we have the presenter? Yes. Oh, great. And you are. That's fantastic. Okay, and Jad, you're there. That's brilliant. Automating change request validation, do we have? Brilliant. Okay. John? That's you. Great. And do we have Tabina here yet? Brilliant. Okay. And yes, we'll go to Suzanne, because I know Suzanne. An immersive virtual reality conference. And you are. Okay. All right, that's fantastic. Well, look, we've got someone from every paper here, so thank you very much for coming to Collaboration and Design Support Systems. I'm the chair, Dermot McMead. We've got five quite different papers here today, so it's going to be quite an interesting session. And I guess without further ado, we'll make a start. So if I could have Shu with the effects of hints on user safety behaviors in VR construction simulator. Thank you.
Just to let you guys know that I will raise my card when you have 5 minutes left for your presentation. Just a reminder.
Okay, good morning, everyone. So I'm Xueqing Lü, and I'm presenting the PhD work today done by me and my supervisor, Dr. Stephen Davis. So this idea actually comes from my master's project. So in my master's, what I did was to test the effect of salient zero sound and some visual hints such as co-workers to people's safety decisions. And as we can see that we have a worker warning people not to go through a dangerous space, and we have the barriers around, and some co-workers using a safe route. So the layout of this environment was we have a shorter unsafe route and a longer safe route, and we want to see whether people take the shortcut. And what we found out was that salient sound can help people to create a sense of normality when there is the related visual assets, and people do learn from mistakes. But at the same time, we still don't know what's the underlying reason how people learn. For example, we find that people look at the hints, but their behaviors were not changed based on those hints. So we're thinking, do they really see the hints, or they just look at the direction of the hints? So that's why we decided to use eye tracking headset and EEG device to measure people's attention. So the FOV is the eye tracking headset. It's got cameras inside to measure people's gaze point, and it's got a built-in Unity package. So on the picture on the right, there's the green dot representing people's gaze point. So to avoid people guess the reason that why we use the eye tracking headset, we actually make an interactive function. So there's the hint button on the blackboard. When people are looking at the hint button and press another button on the controller, they will activate the hint. And the hint is an NPC telling them where the item they need to collect is. So the reason that we want to have this hint is to make sure that people work on the routes that we design. So they walk to the NPC, and the NPC mark the item they need to collect on the map for them. So in between the NPC and the item, there's the hazard. And the EEG gives us attention, meditation, and the combination of these two. And at the same time, we get different bandwidth, 8 different bandwidths of brainwaves. In this study, we're looking at attention and alpha wave, which is related to problem solving and learning. We did a pilot study on 6 PhD students in the School of Civil and Environmental Engineering in UNSW, and there were 10 items to collect to build a scaffold, but only 1 student finished the whole tasks wearing the VR headset, and the other 5 felt pretty strong VR sickness. And that student who finished all the tasks actually had 2 years first-person game experience. So that's the point how they can reduce the sickness. So after that, we decided to split the 10 tasks into 2 sessions, half of them using laptop and the other half using VR headset to reduce the exposure time in VR headset. And at the same time, we can compare the people's safety decisions with the 2 displays. And we invite students, telling them we want people who don't have motion sickness or VR sickness, which has similar symptoms. And because in our environment, we can actually use things like teleport, because they may just skip the hazards. And what we do to reduce the sickness is to change the way to turn. So before we use the thumbstick, when people push the thumbstick, they just keep turning. And now we change it to turn 30 degrees when each time the thumbstick is pushed. And just a little suggestion that if you have to do something to make people sick, maybe prepare some tissue for them and water, because they may ask for water and they may sweat. So these are the 10 tasks. So they need to collect 10 items. We put 8 hazards in it. The reason we don't put 10 hazards is we don't want people to intentionally look for hazards when they're doing the tasks. And in the 8 hazards, there are 4 of them above eye level and the other 4 below or at eye level, because in my master's project, we put 2 hazards, one above eye level and another on the ground. And we found it might be that the hazards above eye level are harder to identify. And we add different hints to the hazards, like sound of the engine, barriers, flashing light, warning signs, and some dust or verbal warning from the co-workers. So here is a video of the test environment. Before they start their task, there is a safety manager asking them to wear the personal protection equipment. That's a hint for them to realize that they need to care about their safety. Then they go to this quest system, which is the blackboard, and activate the quest. We have text on the left and image on the right. Then I click on the button and try to find the NPC called Tom. The NPC marked the item on the map for them. Then they go and find the item. The hazard that they are passing is the electrical cables in water. So we can see that when they're collecting the item, they are actually still checking the cables around. And we thought that when we add hints, people actually can identify more hazards and avoid the injury more. But actually, except for warning signs and beeping sound, all the other hints reduce the chance of hints being identified. Let's just think of a real-world scenario. If we're on the way to meet a friend, and we pass a roadwork, and there's barriers around, do you really stop and think of what's the hazard? Or do we just walk around? Maybe that's what happened in this environment. And then we compare the hazard identification and injury rates for the hazards above eye level and at or below eye level. So the hazards above eye level are less likely to be identified and injure people more. And we compare the two types of displays. So people injure more times with laptop than with headset display. And after they injure the first time, are they willing to injure them another time using the shortcut or find another way? So when they're using the laptop display, they are still think they are playing a game. So they will injure them more times after. And from the EEG data, we can find that the average attention level is higher when they're heading to the blackboard, and the alpha wave is higher when they're heading to the blackboard, heading to NPC, and when they're injured. But that's just the average level, and we know that brain's activity actually happens pretty fast. So these activities usually last for 1 minute. And now we need to look at the details of what's happening. So here is a video. We do a screenshot, screen filming for the game they're playing, and at the same time we record the brainwave. So in this part, the red line is the attention, and this one is meditation, which is the green line. And there's the delta, theta, low alpha, and high alpha wave. So start from when I first get to the entrance of the site. And now they're looking at the map, try to find where the blackboard is. So during the time when they're trying to figure out where the blackboard is, their attention increases. And now they prepare to get ready to press on the buttons, look for the quest. Here I cut a little bit because this participant actually thought this guy is James. So during the walk to this NPC, the brainwave is pretty stable until they see the NPC waving at them, and they are focusing on the NPC.
I marked it on the map for you.
And now they see the shadow of the trench box. So they're walking around and they look at the trench box. And when they put up the map again and try to figure out where the blackboard is, their attention increases again. I think this video is pretty long, so we jump to the end a bit. When they get injured, and looking for what's happening, their attention increases. Here, the attention is almost zero. I guess they're just willing to use the shortcut and injure them again. And he pull up the map again, try to figure out where the blackboard is. The attention goes up again. So we can see that during the wayfinding process, and when they're injured and trying to figure out what's happening, their attention actually goes up. And the findings from this experiment. So unfortunately, we haven't got enough participants so far, because the time that I do the experiment is actually exam period, so we can't get enough students. And based on the sample size, 18 students, 10 in the control group without hints, and 8 in the experimental group with hints, we find out that except for warning signs and beeping sounds, all the other hints reduce the chance of hints being identified. Hazards being identified. And when the alternative route is more accessible, people would change their unsafe behavior earlier. So in the scenario that we saw when the participant was injured, that's at one entrance of the building, and the other entrance is all the way across. So they have to decide whether to injure themselves again or use the longer route. But for the other hazards, like if the hazard is here and it's a pretty open area, they just walk around. And the hazards above eye level are less likely to be identified. Hazards above eye level injure people more, and people are less willing to injure themselves when wearing the headset than using the laptop. And people's attention level and alpha wave are higher during wayfinding and injuries. So based on this, our future study will first expand the sample size, and then we'll compare the visual hints such as barriers, warning signs, and flashing lights. Then we compare the audio hints, like verbal warning telling the hazards, verbal warning with not telling the hazards, and beeping sound. And we'll compare good and bad hints, such as when their coworkers are doing things unsafely, they will injure, or they will be lucky and not injured. So do they copy their coworkers' behaviors? And then we'll compare the training effectiveness of video, VR, and MR. Okay, that's all. Thank you for listening, and any questions?
Yes, any questions?
Thanks for the presentation. So I have two questions, but I think you'll be able to answer them both in one. We'll see. My first question goes back to your initial test group, where you mentioned that you had 5 people out of 6 getting motion sickness. And did you have a chance to look into that and find out why such a big number? It's a small group, but why a big number of the group had motion sickness within the VR? Was it something to do with the inbuilt Unity, or I don't know?
So in the real world, when we are turning, our eyes, gaze point is usually fixed at one point. But in the virtual reality, when we are turning, our head is actually follow our body. So that causes the dizziness. And when people have more experience in first-person game, they get used to that. So what people usually do to reduce the sickness is to use teleport. That's to point at a place, and then the next second you just jump there. But in my experiment, I can't do that because we don't want people to jump over the hazard. So we just make the turning easier for them. So it's like the next second they jump 30 degrees.
Okay, that answers the first question then. So then my second question becomes, within your VR, are you focusing on the walkable VR? Because your example showed a walkable space, but in some of the tests it looks like it's a seated experience where it's just the gaze and the 30 degrees changing. Because based on what you said, and also a little bit in my experience, it's exactly as you're describing, in that if you're walking, even with the headset on, you're less likely to get sick because your brain is hooked to thinking you're actually going somewhere. Whereas if you're seated and only your head is moving, then there is confusion and then sickness. So are you focusing on seated VR or walkable VR, or are you combining both?
In my experiment, it's walkable VR. Yeah.
Other questions? Yes.
Yes, thank you for your presentation. I have 2 questions. I just want to know what you mean by MR, mixed reality, because I'm not
Yeah.
presentation. You mean with the HoloLens, for example?
Yeah, HoloLens.
Okay. Thank you. And my second question is, do you think it's interesting, for example, to add a stress factor, like a timer, or maybe a number of unnecessary information feedback, so you get, less concentrated, and you see if people will act differently if they are under stress?
Yeah, the stress factor we have is to pay people more when they finish the task faster. So if they finish the both tasks in with laptop and VR headset in 20 minutes, they get $20 payment. No, within 20 minutes they get $30 payment, and more than 20 minutes they get $20 payment.
Okay, we've maybe got time for one more question. Okay, it's going to be my question. You're gathering EEG data.
Yeah.
Oh, fantastic. Have you had a chance to analyze that data?
Not yet, because I was still doing my experiment the day before I come here.
Okay, all right. Well, I look forward to hearing what you learned from the EEG data. That is fascinating to get what's going on in people's heads while they're doing this. Okay, well, thank you very much. And now could I invite Jad, speaking on the performance effects of using mixed reality for electrical point layout tasks.
All right. Thank you, everyone, for joining us. So this research is part of a bigger research that is my dissertation, essentially. So in my dissertation, I'm looking at using AR for pre-construction, during construction, and post-construction tasks, AR, MR, whatever you guys want to call it, to get the attributes of the tasks that are enabled by AR. So we can know pre-hand, if I give you, I need this much accuracy, this type of task, I know whether or not AR is a
They're like, okay, we're all done.
Yes, 3 seconds. So we don't cut from now on.
So, in all of my research, this is kind of what's been leading my thought process, is we currently develop building information models. We have BIMs that we spend a lot of time on developing. And then to transfer the information to the site, we usually take sections and cut different 2D plan sheets, give them to the workers on the site, and they have to reinterpret those plans into a 3D model to build it. And in the best case scenario, the BIM that we have and the model that they have conceptualized in their heads match perfectly. And that doesn't really happen very, very often, because sometimes you forget to cut all the sheets that you need, sometimes you lose paper plans, sometimes they misinterpret it. And so then you end up with problems. And the overarching theme of my dissertation would be, so why don't we just give the model to the users through augmented or mixed reality so they can use it directly. And obviously that can't work for every single application out there. Sometimes you need the 2D plan sheets, sometimes AR isn't a good fit. So that's why we've been trying to explore and see where does it usually work. And so for this experiment, we've done electrical layout. So before you install electrical panels, you have to go into a room and say, I need an outlet here, a switch here, Ethernet port, so on and so forth. And then the installation crew would come and they would install those devices in your room. And currently what you do is you have a 2D plan sheet, usually a top view, and you have elevations and distances from corners because you don't have walls, and you go and start taking measurements and marking the walls. And that takes time. And so we thought maybe we can take that BIM, give it to the user, they'll walk in, they'll see just glowing panels of outlet, switch, so on and so forth. And so we partnered with an electrical company in Phoenix. We used one of their conference rooms, not an active construction site, because we were still trying to see if it's a good fit. It had an awkward shape. I don't know if the 3D representation here shows it. It's a 90-degree on this side of the room, but it's like 140 degrees there. And we used multiple different layouts on these 3 walls to test this AR application. So I'm going to focus on one wall just to give you the designs that we had. So we had 4 different designs going forward. The first design had 5 electrical appliances or electrical devices to be installed. They were all different devices, but all on the same elevation. The second one had 5 devices, all different devices at 5 different elevations. The third one, we had 10 devices, all different devices at different elevations. And finally, we had the fourth design, 5 devices, all outlets at different elevations. And the differences between the designs was for another aspect of this, where we were looking at complexity. So it's like a more complex task, still suitable to use AR for. I'm not going to be presenting that portion of this research today. So what we did is we had the participants come in and lay out the rooms. I'll share the exact methodology in a minute. And during the time that, after they finished layout, they were filling questionnaires, and we were actually using laser measures to take the x-axis and the elevation axis distances. So essentially, we were creating a coordinate system for every point that they laid out, and then we would be able to compare that with the BIM model that we have, so we know how accurate their layout was. We also timed them, so we know how fast they did things. And so we had 4 designs, and we wanted every participant coming in to do all 4 of them. And since we had industry participants, they all had different years of experience, and obviously we wanted to try to remove all external factors from the comparison. So instead of having just the 4 designs, we had 2 versions of each design. So design 1A, design 1B, and they both had 5 devices, different elevations, different devices, but they weren't exactly in the same spot. So if I was a participant, I walk in, do 1A. If I do 1B, in my mind, I'm not repeating the same task. I'm doing a completely new task. And we didn't share with them the characteristics of each design. But we can do one with AR, one with paper plans, and we can compare them one-to-one without affecting our comparison. But there's other factors, so here's what we did. We randomized the list of devices, of designs that they will lay out. So for example, the first participant comes in, does 2B, 1A, 3A, so on and so forth, and all the A variants are with AR. All the B variants are with paper. Second participant comes in, he does the exact same listing, but B with paper, A with paper, be with AR. So now this is called a double counterbalance design experiment. So we remove all those nuances. Third participants comes in, we randomize again, A, AR, B, paper, so on and so forth. So the participant would come in, they filled out a pre-questionnaire just to get their years of experience, what do they do currently, stuff like that. Then they would go do the first design, fill in as a TLX, which captures cognitive workload, not as cool as the EEG monitor, but it captures some data. They'd go back, do 1A, and in the meantime would be measuring the points. So and they would keep doing that until they were essentially done. Fill a post-session questionnaire, and we video recorded everything, so we can later on measure the time and get how fast they did tasks with AR and how fast they did with paper. And the results, we focus on multiple parts. I'm going to share the accuracy and the time. So, accuracy-wise, before we get started, we noticed a bunch of participants actually, when they were laying out with paper, they did a very common mistake. So they would start, A goes in close to where it needs to go, B maybe exactly. C and D would be 2 points close to each other, one at 1.5 feet, the other one is at 5 feet. They would look at the paper plans, okay, so this is at 1.5 feet, this is at 5 feet, and they would switch them, which essentially creates a 3.5 foot, a meter of inaccuracy. And if we take that into consideration, we're handicapping the results anyway. So we used Tucker's outlier removal process to remove the big outliers from both data sets. With AR, sometimes the whole model shifted by 3 feet because of tracking problems. So again, you're adding so much inaccuracy. To remove those outliers to get good data sets, we still had like 1,400 points, so we were fine. So if we take an average point, this is where it would be placed with AR, and this is where it would be placed with paper. So it's about 1 inch off on the x-axis with paper, 0.2 inches on the y-axis. With AR, especially on the y-axis, it's a lot more. Which on if you look at just the numbers, you'd think, oh, AR is so bad, we shouldn't be using AR. Which you're right if you care about that much accuracy, but in a residential setting, especially or office setting, or anything that doesn't require super accuracy, especially in some places of the world, in the US, for example, when we lay out electrical systems, we install them to the nearest stud, not exactly where they go on the wall. So you'd have studs, and if it's in between studs, usually what happens is you get it closer to the closest stud, at least on the x-axis. The y has to be accurate. So what we did propose to that company that we worked with is, look, you can go using the headset, just lay it out on the ground, leave the stickers or the marks on the ground. Then you can use your tape measures for the 1.5 feet or 5 feet and be accurate, and you'd get the best of both visualization methods to capitalize on the benefits of both visualization methods. On a more technical note, so the difference is 0.2 inches on the x-axis and about 1 inch on the y-axis. On a more technical AR note, we used marker-based AR to show the points where we need them to show. And we noticed that the farther you get from the points, the more deviation you get. So this is the linear regression model. I have a better visualization here. So this is how you think the accuracy, it would be the same on all points. If you were centered around point C, you'd see a little bit more deviation on B and D, and significantly more the more distance you are from the center. So this is important because you can correct for this. If we can predict how much the deviation, how the model is deflecting as it shifts from the center, I can correct for that in BIM and end up with accurate viewing until the technology catches up and everything's accurate anyway, at least to some extent. So one more thing that we looked at is the difference between accuracy and scatter, and I have a nice graphic here to show. So we have accurate viewing, inaccurate viewing, low scatter, and high scatter. So if we're in the first quadrant, you'd hit the center every time. You're seeing everything where it needs to be, and you're good. You place things where they need to go. If you have accurate viewing but high scatter, you see things where they should go, but you're still not quite on the center. On the lower side, inaccurate viewing with low scatter is you see things shifted, but all the points are close to each other. And high scatter is just with high inaccuracy is the worst you can be. So we looked at how does AR scatter or variance measure up to paper scatter or variance, regardless of how accurate it is in the first place. So if this is a point, this is where all the AR points are with respect to variance. So they're not directly on top of it, but that's the cloud, the AR points cloud. Versus this is the paper points cloud. So although my viewing is inaccurate, so the user is not seeing the point where it needs to be, they're placing the points close to where they see it. So if we can fix that location, all of a sudden you're significantly more close than paper allows you to be. So, time, and this is the fun part. AR versus paper. With paper per point, it took about 27, 30 seconds to lay out each point. With paper, it took about 1.5 minutes. So that's about 3 times faster when you're using the AR. And that's why we think the hybrid method makes a lot of sense. If you go along the walls and just lay out everything on the x-axis using the fast, not very accurate AR, and then you use the tape measures to get the y-axis and hit that point exactly where it needs to be in the stub, you're capitalizing on the benefits of both visualization methods. So that's my presentation. Thank you, everyone. And does anyone have any questions?
So people had some kind of headset on.
Yes, they had the HoloLens on.
How did the HoloLens know where it was?
So we used marker-based. So we had the design of the room, and we picked a corner, and when we got the BIM models, we used the marker on the corner to locate everything. So we had a marker. Every time we changed the design, we scanned the marker again, and everything would pop up. And that's the center of that deviation space on the side.
Okay.
For the hybrid method, do you still kind of induce the error of that? So you mentioned when people use the paper, they got the heights off a little bit.
I don't think that you use the AR for the y-axis or for the elevations altogether. You just put the so we used stickers to mark the walls. You just lay the stickers near the studs where you see
But when they did the paper method, didn't you say that they sometimes switch the height?
Oh, so that you can't, that you probably can't fix. Although with AR, it's going to give you a very good feedback. So maybe you keep the headset on, but still use the tape. Because if you use the tape and you place it here and you see it 3 foot on top, this probably needs to go somewhere higher, and you'll double check your measurements. So that might be a good.
Yeah, I was going to ask if you'd have it on the headset, if you just have the height where they.
Yeah, maybe. Maybe you'll have the measurement on the headset and don't use the tape. Yeah.
Do you have an idea which part of the accuracy was based on the, I guess, inaccurate tracking and which was on the usability of the HoloLens?
So the variance study that I showed is what kind of tells me that it's based on the HoloLens not showing things accurate. Because all the points were very close to one another. So that tells me that we had 34 participants that did 50 points each. And they were very, very close to one another. So 1,500 points that are very close to where, between all these participants, I think that they're seeing it correctly. It's just not accurate in of itself. It's the HoloLens' fault, that's what I think.
And the paper, the variance on the paper is down to misreading or transcribing
So
numbers?
that's still with removing the outliers.
That's
So
still
with
removing the
with
outliers.
paper, and the variance increases with experience. So what we think is they get it close enough, and they know by experience that close enough will cut it, and they don't actually take the time to get it to the perfect accuracy. And so
that was
they,
actually my next question.
they get
Do you find the
they get
experts
lenient.
making presumptions about it?
Yes, so the experts actually fared significantly worse than the non-experts in both visualization methods.
Really?
And when talking with them, when talking with project managers, they're like, they know this, no one's gonna check if it's 18 or 18 and a half inches off the ground, so what do they care? So.
That's fantastic. Any further questions?
Did you visualize any kinds of measurements
No, so they only use vision. So you see the point, and one of the objectives of this is we have a pretty strong labor shortage issue in the U.S. at least, and if you, this kind of thing, so we had interns do it, we had non-construction people do it, and they all do it equally similarly. That's another paper. So we're thinking if we can free up the experts to do something else that actually needs experts, we want the whomever's doing this not to need almost any training. Just put on the headset and go do the work, and you'll do it good enough. So that was the original motivation. So we didn't let them use any tools when they were using the AR headset.
With the paper-based process?
The paper-based process, they can use anything. So some of them had their own tapes. Some of them asked for like marking tape, blue marking tape, so they can mark where they are. Some of them had pencils. They could use whatever they wanted to use with the paper set. With the AR, it's just the headset.
But there were no measurements on the paper instructions, so they had to guess the.
Oh no! On the paper instructions, it was exactly what they would take to the site. So we had their team produce standard paper plans to use on the paper side. On the AR side, we just controlled. You just use the AR headset.
And this is your PhD dissertation?
This is part of it. So this is.
Well, I think
first
we should
one.
all commend Jed on, I think, a fantastic methodology. I think just quite a stunningly clear methodology in it there.
Yeah.
Wonderful, Jed. Thank you.
Thank you.
Okay. Our next paper is Jonathan, and he will be speaking on automating change request validation using industry foundation classes and natural language processing.
Sorry. Yep, thank you for coming, everyone. So I'm going to be talking about automating change requests, validation using industry foundation classes and natural language processing. I'll give a brief outline, so I'll give a bit of background on me, the project, the rationale for it, the Elwin system, which was the sort of system that we're trying sort of experimenting with commercialization, with which we build this research. I'll look at the change requests and the NLP approach we have for processing them. Then I'll look at the validation methodology, and then finally I'll look at some of the future work. My background's in computer science, software engineering. This project was undertaken as part of a KTP associate, which is a knowledge transfer partnership. This is a system in the UK where the government sort of gives finance to universities and companies in order to try and build bridges between the universities and companies to try and disseminate some of the research knowledge into industry. And I work for a company called Applied Integration. They're one of the UK's leading system integrators. They work with Siemens, PLCs, that kinds of thing. They're a reasonably small company. They're about 20 to 30 people, but they have a big investment in research. They really see the benefit of research. And this project kind of came about from their work that they do in the MEP domain. So they were quite far down the chain, and they obviously they see the knock-on effects that changes can have. So if you make a design change, then it affects everyone right the way through the chain. So they don't have as much expertise in the construction domain, but that helps with T-Side and Nash, his department, who have a lot of expertise in this area. So that's kind of how the project came about. So the main rationale for this is there are a lot of errors in construction projects. There's estimates from anywhere between up to 80% of the cost of a project can be in changes, and a lot of these, it's believed, occur in the design change or with consultants. There's been a lot of work done on change detection, including the system that we were working on as part of this project. That leads into the research that we've been doing. So this is a bit of overview of the system. It was originally called the Elwin system. We have renamed it to Architrack at this point, and it's seen a UI redesign since the paper, so it will look a little bit different if anyone recognizes it. It's a web-based system, so we use Angular for the user interface, C#, ASP for the backend, and we use XBIM as our method of processing and reading the IFC files. Yeah, and its main feature so far is it generates reports based on IFC files. So if you upload some IFC files, so you can generate a comparison between the IFC files, and it'll show you a list of the objects that have changed, the details, things like that, and you can see a little preview in the browser. So I'll show a quick demo in a second. The demo shows an overview of the main features of the application. It uses the built-in smart duplex model as kind of the test case, and you'll see that throughout some of the other demos later on in the presentation. It's developed to be kind of a pragmatic application. We don't want to force a methodology of working on any of the companies that might want to use our product. I think that partly comes from slight lack of domain knowledge on applied integrations on my part. We kind of just want people to integrate into the current workflows. We're not trying to force anything on anyone. And it's built using web standards, so we designing it to be pretty extensible. We have ways that we could bring this to mobile. We're using IFC files as the main source of input right now. I should clarify, I'm sure everyone knows, but IFC files, like the kind of standard interchange format for 3D building models. And we have plans to open the API for public use, so other developers can get a key and they can start building on our software. The current version of the UI is built all on top using our API, essentially. So the foundations are there. So this is captured within the browser. So this is the main interface of the application. So in this demo, I walk through, I create a new project, I upload some IFC files, and then I generate a comparison between them. This is me just uploading two different versions of the duplex. The first version is the standard version that anyone can download from Building Smart. The second version, I've made some change to. So in this case, I've moved some furniture around and deleted some furniture as well, I believe. So at this point, I've uploaded both IFC files. You can see a little preview in the browser. Now I'm going to generate a comparison between these files. So yeah, so you can't really see the differences at this stage, but they are both different, trust me. Yeah. So now I'll go through and I'll create a comparison using both versions of the IFC files. And this is the comparison. So you can see it generates a report, a list of the objects that have been added, deleted, and changed. You can view details of the objects, and then the buttons at the top give you a little preview of the changes. So you can see it's grayed out all the colors, and it's highlighted the specific objects that have changed. So it has different colors for additions, deletions, and changes. And then I believe, yep, you can click this to zoom in on specific objects within the model. So for the change validation, we sort of imagine this kind of scenario from talking to some of the companies that we have like relationships with. It was very common for them to have the architects design a version of the model. They'd then send it out to contractors who'd make some changes. It was very difficult for them to sort of keep track of all the changes to identify the changes that had been made. It's a very manual process. So this is the kind of scenario that we were envisioning. The designer makes the initial model. They'd sort of submit that to our system. They'd then submit a change request for any additions that need to be made or corrections. That would then be sent to a contractor. They would implement the changes. They would re-upload a new version of the model. And then this would then be automated. So our system would then use the change requests, the plain text that the architect sort of input, and then that would validate the changes that are being made by the contractor. And then this would come back to the architect to have the final approval on whether the changes should go through. Okay, so this is a screenshot in the top left from the old version of the UI. As I said, I've rebuilt the interface, so not everything's back in the current version of the system. But this was sort of the idea behind it. So you could create a new change request. It has a big text box where you can just enter the change request in plain text. You can then click the parse button, and then this will parse out the properties into the little boxes below. So this will detect the objects involved in the change request. So the focus for this change request was on objects and sort of moving them around, deleting them as sort of this test case. So you can see it will parse out the type, the key object involved, and then the locations of the object involved. The NLP sort of processing sequence is built on Core NLP, and then a series of state machines built on top of Core NLP. So this is quite an old information extraction technique, but it's really effective. So this comes from my background in using NLP to parse out objects and requests and requirements from clinical guidelines. So there's quite a lot of similarities between the two. So it uses a system, it's kind of like regular expressions, if anyone's familiar with that. So you would have like, if you wanted to parse like animals or something like that, you might have like cat and then like cat S for like plural. But this using advances in statistical processing like Core NLP, we can raise the abstraction a little bit. So we're not working at the pure lexical level anymore, we're working at tokens. So you can see in this case, the first stage is to classify nouns as objects, and then we can apply successive stages onto that then use the parse for each, and they can use the custom tags that we apply. So you can see for the end location, we have a pattern that's similar to like to object, that's marked as an end location. And then we can identify the start location by using a pattern object to end location. So it's quite effective, relatively simple techniques, but quite effective. So this is the main overview of the validation process that we use. So it uses the set of changes that we generate from the core system. It sort of brings in a formalized version of the change request. So this has all the information we need in terms of the object name, the locations involved, that kind of thing. And we can simply just do a check with the comparison that we made earlier in the stage. So it's quite fast. It usually leaves much less objects to check than checking through the entire version of the model. So this is a video capture from the desktop debug interface, again, because I'm rebuilding the main interface right now. But this just shows some examples of parsing out different types of change requests, parsing out different types, different objects, different locations, that kind of thing. Yeah. So this is another demo. So this uses the change requests that I mentioned here. These are some changes that were actually made to the duplex shown earlier in the process. So you can see in the files, it's actually using the same IFC files that we showed the comparison for earlier in the system. So this is moving the sofa from one room to another. This will validate the change request. I'll then make some changes to break it just to show that it is actually working. And then I have a change request to delete an object that's validated as well. And then just to show again that it is real, you can see the preview of the objects. That was the table that was deleted. View through the web interface of the system. Yeah, this is the couch that was moved. So So this is the methodology that we've outlined. So the previous sort of validation process, that works well for modifications and deletions. Additions slightly more challenging. The way we approached this was in a very sort of text-to-scene approach, if anyone's familiar with that approach. So there's a problem that exists in that space called grounding. It's where you take basically objects and things mentioned in plain text. So if I say move the couch from the living room to the upstairs bedroom, it's the process of how you actually map those to concrete objects. It's very, very difficult. But this is sort of the process that we outlined that could be used to sort of validate change requests. So we take the object name that someone's entered in the change requests, and then we can have a set of synonyms, and then we can break. We basically convert the object in the change request into a bag of words that consists of the name that was entered, all the associated synonyms, and then we can associate that with the names in the IFC file. So a lot of the times the objects mentioned in an IFC file will contain some sort of English names, just software, like in this case. And then basically we can use that process to try and find the best match. So we use this process in my thesis to map actions extracted from clinical guidelines to planning operators for an AI planning domain. We use a similar sort of technique of converting them both to bag of words and then measuring the overlap to come up with a semantic relevance. So the future work for the system, we need to improve the NLP. So there isn't really, we found, a formal outline change request process that anyone's using right now. So we kind of just want to get it into users' hands, generate some more data, and then we can generate a real evaluation of the NLP approach. We probably use something like F-measure, if anyone's familiar with that. It's quite a common way of measuring the overall accuracy in information extraction. We also want to improve just the overall recognition, the overall system. So we could potentially see this as a case where it doesn't just support change requests. You could essentially create a set of static rules, like a room, every room has to have a door, and then our system can just apply that every time. Sort of like unit tests in software development. So when you're developing things in software, you have a set of tests that you essentially keep alongside the product the whole time, and you rerun them every time a change is made, just to validate that nothing's been broken. We think an approach like that might work quite well. And then, yeah, we want to just continue integrating this into the overall process. Thank you. Any questions? Okay, so we're not basing it off that right now. We're using the spaces. So we're kind of making the assumption that if you have like a room, like in that case in the couch, that when we get the IFC data, it's semantically associated with the room. So it's not as granular as like the XY positions, that kind of thing.
Can you process batch requests? So if I say, please remove this and add this and then delete these two?
Not right now. So the way we would probably do that is we would associate. We would essentially, I have a vague plan for how to integrate that. So if you submit like a paragraph of change requests, we'd assume that every sentence is kind of an individual change request. There are ways that we could handle if you have like delete this object, delete that object, and delete another object in the same sentence that we could handle, but it starts to become tricky when you bundle too many things together.
Can you use it backwards if you've got two big models? Can you work out what the difference between them?
I don't know right now. It works from IFC files. So it should work in anything that you can export IFC to. But this part, we haven't released this software yet. So we hope to sort of get it into customers' hands in like December, January kind of thing. And then hopefully we'll go through a lot of testing where we can see what things are actually breaking and working, for sure.
Yes, I have a question just to bring interest. Which framework did you use for providing 3D preview?
That is a part of the XBIM library. So they provide functions for reading the IFC files, but they also provide visualizers for WPF on Windows, and they have a JavaScript one as well.
And I have a question about the natural language processing.
Yep.
At the moment, one imagines Google and Amazon have got incredibly powerful, sophisticated natural language processors. Are you using them, or are you using something different? Will you use them?
So the kind of approach that they use is very deep understanding. The kind of approach that we're using is kind of like bypassing that problem, classifying it more as an information extraction problem. So we do benefit some of that in terms of like the core NLP. That's a statistical parser that generates a full dependency graph for the sentence. But then the layers that we apply on top of it are relatively simple, so it's not deep understanding. So.
All right. Can we all thank Jonathan once again for his presentation? Okay. Do we have Tabina here? Yes. Great. Okay. Tabina will be speaking on impact assessment of digital technology on productivity and housing affordability. Do you have your speak?
Yeah, I do.
This one.
Yeah, the top one. No, the top one. Yeah. Thank you. Good morning, everybody, and thank you for joining me for my presentation. It's a review of digital technologies for productivity and productivity gains in the New Zealand building industry. I'm Tabinda Chaudhary, and I'm a PhD student, first-year PhD student at the University of Auckland Civil Engineering Department. So today I'm going to go through some introduction on the topic industry signals, some key terminologies, the aims and objectives for the paper, the research methodology that I used, some key findings, and a conclusion and the research significance. So getting you started on the background for this subject. Now, the mega trends of the global construction of the world, like such as the urban population, is constantly remodeling the construction industry to improve productivity, to provide more affordable housing and expand the capacity of the infrastructures. While the global construction sector has a record of poor productivity, the scenario in New Zealand is much alike. In New Zealand, the construction industry is the 5th largest sector, and it yields about 8% GDP per year. It employs 8% of the workforce, and 87% of the urban population is in Auckland. And it's predicted that 75% of the construction will be held in Auckland alone, and the cost of the dwellings has gone up by around 27% since 2007. Now, this poses a struggle for the largest city, which is Auckland, leading it to become a potential asset bubble. So in New Zealand alone, 24,000 houses are built each year, and the rebuild of Christchurch is going to take up a large part of the national construction capacity. On average, the number of houses built in Auckland is 7,200 against the modest Auckland plan, which is 2050 to build 14,000 houses every year. So construction industry is said to have the lowest productivity, and some of the reasons explained are because of difficult on-site management, poor safety conditions, shortage of skills, and lack of innovation embracing practices in the construction industry. Moving forward, the Building and Construction Productivity Partnership has come up with the motive to increase productivity by 20% by the year 2020, and the government scheme, which is called the Kiwi Build, aims to build 100,000 homes in the next 10 years. And for this, going digital is a solution because the industry can then shift towards digitization in order to improve this sector productivity, and this is where my research comes in. The construction industry is among the least digitized, and some of the reasons are because of the lower availability of funds, because of the affordability issues, resistance to change from the traditional practices to move on towards something new, the threat of the new terms and conditions, and the absence of the condition of contract, which is the NZS 3910, and the risk aversion towards adopting new technologies. The industry signals. So my research aligns with some of the industry signals, such as the National Science Challenge, which is to build better homes, towns, and cities. The BRANZ, which is the Building Research Association of New Zealand Industry Research Strategy, and the Industry Needs Survey to provide more affordable housing and increasing the productivity. So what exactly is productivity? In construction industry, the productivity is the investment in capital for labor, raw materials, and in return of this against the profit from the scale of the product. And why is it important? Is because 1% in increase in productivity would indicate $139 million of GDP in New Zealand alone. For the scope of my project, the digital technologies will be referred to as, for the scale of this paper, actually, the digital technologies are referred to as the advanced ICT, the information and communication tools, that is going to improve the productivity and also the cost efficiencies across the construction life cycle activities. So construction life cycle activity is embedded in the management of all the construction projects to lower the whole life cost, to improve the overall productivity and increase the value of the services. So the overarching theme of my research project is to assess the impact of digital technologies on construction productivity, and we aim to signify digitization as a function of productivity performance in New Zealand building industry. And the objective of this work for the paper was to examine the potential of digital technologies in construction life cycle activities. So how digitization operates across the New Zealand construction sector as yet is not well understood, and the lack of research to understand the impact of digitization productivity creates a gap for my research. Because it's a literature review, it's a theoretical exploration of understanding the potential of digital technologies, the research method used was pretty much straightforward. So I've used the basic search by the title, abstract, and keywords using Scopus as my main source of literature. And I've shortlisted about 144 papers just to find out the key functions of digital technology that can improve productivity and the cost efficiency. So based on, these are some of the top journals that had the most information on digital technologies being utilized in construction that improves productivity and as well as the cost efficiencies. And the top one was Journal of Automation in Construction. Among the list of countries that were identified that have contributed to papers on construction, on digital technologies in construction, USA, Canada, and UK were the top ranked, which seems logical because the government and the industrial practices, they emphasize on implementing digital technologies more in these economies as compared to other countries in the list. And there is an increasing trend on between authors to focus on digital technologies in construction, on how they can work with the industries, and the increasing trend, as you can see. But then there is also a decrease, which can be a bit misleading, because during my search, I had very much specifically searched for the papers, such as I said, digital technology is used in construction. I did not specify any digital technology. I didn't say BIM or RFID or GIS in digital technology, because I wanted to see what all are there in literature between 98 to 2018. But the trend seems to be increasing in this past 20 years. These are some of the top digital technologies that we have identified. There were 31 in total, but then I only put up the top 22 technology and the tools that were repeated in the literature. And based on the key functions of the digital technologies. From this list, we developed a framework. We developed a framework for productivity analysis. So the digitization, productivity of the construction life cycle, the top 3 functions that we had isolated for productivity analysis. One is the ubiquitous digital access, the whole building, whole of life decision making, and the cost reduction engineering. So the ubiquitous digital access is the capability afforded by the digital technologies to give access to the information on site regarding material handling devices, or even tracking the worker, or even the worker activity recognition. The whole building, whole of life decision making is actually a concept that was that was commenced by the Building Research Association of New Zealand, and it was there to establish the environmental impact of building designs and to encourage more consistent use of building based on the life cycle consideration. Now, this concept is particularly important in New Zealand because it facilitates a stronger connection between the supply and demand of the construction products. So digital technologies are going to facilitate more real-time data, access to more real-time data, such as the production status across the building life cycle, and this will consequently improve communication, collaboration, and the teamwork that is necessary for life cycle-based decision-making. And the third concept was the cost reduction engineering, which depends heavily on the cost reduction abilities of digital technologies. So when the cost of the facilities are reduced, the facilities themselves become more affordable and therefore more accessible to the greater population. So given the scale of the Auckland housing shortage and the rebuild of Christchurch, the digital technologies or the automation technologies do pose a very beneficial advantage, and that can leverage meeting the housing demands in New Zealand. So the research implications are parted in 2 ways. One is in terms of the literature, and one is practical. In the academic literature, because it's a theoretical-based exploration of the digital technologies applications in construction life cycle, it creates an avenue for those contemplating the study of digitization in the sector. And for practical implication, it's going to increase the awareness of digital technologies, because not many users are still aware of the benefits of digital technologies and are usually risk aversive, and ultimately aiming to increase the productivity of the sector by 20% by 2020. So that's all I have for today, and thank you very much for your attention.
Thank you very much.
Thank you.
Questions? I have a question about the problem of productivity.
Yeah.
In any of the, you touched on a number of different countries that have done literature on this issue. Now, New Zealand has a very, very aggressive housing market at the moment.
Yes.
And I was wondering, do any of those other countries that you've drawn literature from, do they have a similar sort of aggressive market, or are there comparisons that can be drawn?
We can draw comparison from countries of similar economic sizes, such as Sweden or Austria, or even the UK, because they've got like a similar size, and therefore we can draw in lessons from them. And most of the characteristics or the studies that were drawn were actually from those countries. That's why I did show that there was a graph here, this one. So most of the uses or the case studies on how these countries, the top countries such as US, Canada, and UK, have used digital technologies in order to improve their productivity, because productivity has been an ongoing issue in these countries from a long time, and how they have digitized their sector, or they are digitizing their sector in order to fight the problem. So we're hoping that New Zealand can adopt to something similar, because the trend here still is very much behind.
No, I certainly know in the UK we've got a BIM task force, and I was just wondering if we've got any delegates from the US or Canada. Is BIM mandated by government in those areas? No?
US, no. Only in the UK, yes.
No, there
BIM does not have a national mandate in the US. There are plenty of the large US agencies that mandate BIM
Oh, really?
on the project. So, those word it that way.
Okay, all right.
Not a
That's,
consistent national mandate.
well, that's interesting.
There are quite a large number of flagship projects going on in New Zealand that have used BIM, but then again, not across the entire life cycle. Like they have used it for pre-design or renovation, but not from start to end. So the concept of cost reduction engineering will come into effect if technologies such as BIM and other tools such as combining BIM and VR, or combining BIM and GIS, and then seeing the effect from start, from pre-design all the way to renovation, to see the effect. Yeah, that could be, yeah.
Okay, we have time for one more question, if anyone's got a question. Yes.
Did your productivity figures, do they relate across the whole construction sector? Or, because you mentioned housing availability, which is really quite a big thing you see at the minute. Are you going to focus on that to say, well, here's the productivity and these measures are specifically focused to try and make that sector more productive and maybe free up more houses on the market? Is that an intention? Because I wonder why the housing availability was kind of mentioned at the start. And so, if so, have you got figures for that part of it?
No, not at the moment we don't. At the moment we don't, so we will be looking into it on measuring the productivity changes, if that's what you meant.
Well, only because it was part of your opening thing, and I thought, well, because it's such a political thing.
The 20% you mean?
Well, just you mentioned housing availability, and I thought, okay, is this an area you're particularly going to focus on to raise productivity and as a result make more houses available, you know, or,
Yeah.
you know, is that important?
Yeah, that's something we can look into. Yeah, we can definitely look into that because it is going to help in solving the housing affordability issues in New Zealand. Yeah, we can do that. I will consider that. Thank you.
Yes, John.
I think when we look at the adoption of digital technologies, one of the huge benefits is the ability to modularize, prefabricate, analyze, and other types of prefabrication.
Yes.
Have you looked at, and those may not show up as much in just a digital technology article, but may show up in different ways. I'm
Yeah.
wondering if you've looked at ways to find that kind of literature as well that might indicate productivity improvement, but may not directly tie, although digital technologies are a prerequisite for that to happen.
Yeah, we did actually look into it because we've got the prefab New Zealand and what kind of technologies they're using. So we did send out a few surveys just to find out if they're using any latest technologies such as the CNC and so on. But so we're just going to maybe compile the data responses once we have them to know what technologies they're using at the moment, if that's what you meant, right?
Yeah, I guess maybe just a comment that they may not always show up. I guess
Yeah, it doesn't show,
one way to
yeah.
do it, but it may not always show up as a digital technology.
True.
But a construction method that's enabled by
Digital technology, maybe the tools that are being supported, that are supporting the technology.
About
Yeah.
2 years ago, we at the Prefab NZ conference,
Yeah.
we had the CTO from, I think it was Lindback Construction, and one of the interesting points that they made is they do a huge amount of prefabrication in Europe, but they were only just now starting to invest in digital fabrication. And that first it was figuring out their methodology and where the opportunity was with prefabrication, and then it was only after having done that that they started to say, well, what is the technology that will help us improve and deliver more on our productivity?
Yes. Yeah.
Okay, look, thank you very much.
Thank you very
It was
much.
a really provocative discussion. And finally, could I invite Atsuhiro to talk on immersive virtual reality teleconference system
Is this the one?
with design change tracking and 3D editing for our final presentation.
Thank you for the introduction. Today, I will present the proposal and development of immersive virtual reality teleconference system for designing infrastructures. Today's contents are as follows. The progress of projects consists of both asynchronous and synchronous works. During asynchronous works, the member of a project each work independently. However, during synchronous works, meetings are held and each member's tasks are stipulated, outlining the responsibility of each member to be completed by the next meeting. Because of advancements in information and communication technology, teleconferences that make use of the internet are conducted more frequently in order to reduce traveling time and costs. Traditionally, remote meetings are held using a flat screen display-based teleconference system. However, with this method, several problems arise. Firstly, the feeling of the participant presence is absent. Secondly, the lack of mutual understanding, especially when design changes are discussed. For instance, when pointing out objects within BIM models. Finally, the editing function in the shared virtual environment is insufficient. Additionally, multiple remote participants are unable to track and understand changes in the BIM model during asynchronous work. In order to solve the aforementioned problems, when comparing civil infrastructure designs, this research developed an immersive virtual reality teleconference system using product models and tracking design change. This research proposes a teleconference system consisting of the immersive VR teleconference system, design change tracking system, and cloud-based 3D editing system. Thereafter, a prototype system was developed. So, immersive VR teleconference, design change tracking, and cloud-based 3D editing have been extensively researched in the past. However, they failed to satisfy the necessary requirements I mentioned. So the proposed system is called Immersive VR Design Teleconference System, IVDTS. Participants of a teleconference situated in various remote locations and using IVDTS are able to share the immersive virtual environment. During meetings, using 3D models, they are able to track design changes and edit 3D models via the internet. As mentioned in the introduction, a project consists of iteration of individual works and meetings. Our proposed system supports meeting as shown in this flowchart. The proposed system consists of immersive VR teleconference, design change tracking, and cloud-based 3D editing system. So when using the proposed system, the position and rotation of users are synchronized, tracked by head-mount displays. The avatars are made in advance. Design changes made among multiple participants have the following features: iteration of the meetings, meetings and individual works, identification of 3D models, inheritance of geometry and attributes of 3D models from other 3D models, multiple participants, and identification of order in which models are edited. Based on these features of design change in 3D models are defined as follows. M is a 3D model, S sub I is a session number, M sub J is a model number, M sub K is a parent of M sub J. P of list of M sub K is a list of parent model numbers. A sub N is a code of engineers who edit the model. T sub Rj is time when the editing of the model is completed. So this slide shows an example of design change tracking model, which we developed. Users A sub B, A sub 1, A sub 2, and A sub 3 changed 3D models. The 3D models changed by users have the information about inheritance defined as this equation. The proposed system uses not only geometry, but also attributes. Operations on 3D models with attributes are as shown in this diagram. We divided operations into two sub-operations. The first operation is operation on geometry. The second operation is the operation on attributes. The operation on geometry is divided into 4 operations: add, remove, change, and move. Whereas the operation on attributes are divided into 3 operations: add, remove, and change. We developed the prototype system for IVDTS. This table shows the software and hardware used to develop the prototype system. In order to construct the immersive VR environment, we use the game engine as our development infrastructure and head-mounted display. Moreover, we use the platform as a service for networking and voice chat to develop the shared immersive virtual environment. This figure shows the view of our participants using a developed system. Within the shared immersive virtual environment, users have meetings. In order to use BIM models in the shared virtual environment, we developed a plugin to extract attributes from BIM models. This slide shows the panel with a diagram of design change tracking. The developed system automatically reads the CSV files with the information of design changes. In traditional flat screen-based teleconference system, the shared environment is displayed on a flat screen display. The presence of users in the conventional system is far from that of real meetings, in which participants share the same room. The developed prototype system would enable participants to share a virtual environment. Therefore, the feel of other participants' presence would be improved. However, the proposed VR teleconference system lacks the ability to show users' facial expression or gestures, apart from the position and rotation of their heads tracked by head-mount displays. The proposed systems' inability to display these facial expressions is problematic. Another problem with flat screen-based teleconference is a lack of mutual understanding of the 3D models. However, when participants use the proposed system, they are able to build 3D models stereoscopically with head-mount displays. Subsequently, participants will have a mutual understanding of the model's 3-dimensional shape during the teleconference. The difficulty in tracking and understanding design change is a 3D model in the 3D models by multiple remote participants is another problem faced during teleconferences. The developed prototype is able to track design changes by dealing with the history of design changes, and users were able to view the tracked design change during the teleconference. The developed design change system, developed design change tracking system shows differences between design alternatives. Therefore, the proposed system is effective in tracking and understanding design changes. A downfall of the design change tracking system is that it cannot register the data of design changes. The registering system functionality to avoid conflict during moderating needs further development to make the progress of project more effective. In conclusion, we propose a VR teleconference system called IVDTS to support the comparison of civil infrastructure designs. IVDTS consists of the following three subsystems: the immersive VR teleconference system, the design tracking system, and the cloud-based 3D moderating system. Finally, we implemented the proposed system as a prototype system for Bridge. Further development is needed on how users are represented in the virtual environment in terms of facial expression and their gestures. Parametric modeling and quantitative evaluation is required. Thank you for your kind attention.
All right, thank you. And thanks to everybody for keeping so well to time. It's really difficult being the presenter that stands between our delegates and lunch. That was fantastic, fantastic work. Do we have any questions? Yes?
Could you maybe talk a little in that future work, what kind of metric or data do you think you will collect to assess some of those goals? What types of metrics do you envision tracking?
What is metrics?
How will you measure the user behavior, whether it's for gestures or for spoken? How will you measure this?
Measure.
For the future.
For the future. So we will conduct we will conduct some we will conduct some teleconference with this proposed system, and we will ask the usefulness or field of users.
I was just thinking, one thing you might consider is compare this to a system where they can't freely navigate, or some other system, maybe like a screen sharing or something like that, where I can't see where another user is, and that may help to identify sort of unique value to this kind of environment.
So I will.
It could be worth considering. Anyway.
So I will. So I will compare with the traditional screen-based teleconference system with this proposed system.
Okay, any other questions? I was wondering, in the environment, you have maybe 2 or 3 people. Can they all edit at the same time?
Yes.
They can all edit at the same time?
Yes.
And is that difficult to manage? More than one person editing the model simultaneously?
Yes, simultaneously, and so there's no So, at the same time, all of users in this with this system can operate the 3D model at the same time. Same time, but
and you can track what each user changes or modifies.
Ah, okay.
Oh, fantastic. Okay, any other questions? Well, I think it only leaves me to sort of thank all the speakers this morning, and we shall not stand in the way of lunch any longer. Thank to all the speakers and all of you for attending.
The first time, like, the service speaker just reset every 3 hours.
There's a funny story of somewhere in the university, a lecturer holding a class, and he got the time wrong, so he came at 10 o'clock, and he comes in and he was supposed to be 11 o'clock, but the entire class come. So he comes in and he kind of starts, and he had told them all to arrive at that time. Give the lecture and left at 11 o'clock, and at 11 o'clock the lecture theatre automatically started up and started to record and recorded nothing for an entire hour, and then that went on to Canvas as a recording of the lecture.
It's just empty room. Oh god. I mean, don't forget your computer.
No, I did not drink mine. Mine's gone fast.
I'll take this back. This is a present.
I don't know. Enjoy that.
Thank you, that was fantastic.
Thank you.
評価方法です。評価方法。メトリックスってのは尺度っていう尺度。例えばその理解がどれだけできたかとか、あるいはそのジェスチャーとかね、なんかそういうこうまあ数的まあできれば数的なその評価尺度みたいなそういうのどうすんのってそういう質問だったんです。
マトリックスが何か。
マトリックスじゃなくて。
が何かちょっと。メトリックス。メトリックスの尺度。それ。知って意味が行列とかの。違う。
まあでもあとうちの人が聞いてたのは、まあ同時に。だから
コンフリクトが。
そうコンフリクトがどうするの？
コンフリクトがそもそも起きない。一つのものを全員が一斉に動かして、例えば粘土が
じゃあ最初に掴んだ人が勝つわけ。
はい。
そういうこと言えばよかった。だからその同時にって言うと全く同時ってことはありえないわけで、例えば橋脚をこうパスとかっていう時にそれ掴んで、でその後から掴もうと思うと掴まないよ。
それは掴んで。
掴まない。どうするの？動かすことできるの？同時にじゃあこれ。
同時に。動かないです。動かないです。何も動かない。本当に。
じゃあサイマルテニアスにエディットできないっていうことじゃない。
サイマルテニアスに。
同時に。だからそういうことで同時にそう。
同時にする。同時にって本当に権限が移るとかそういう意味でよくあるテレカンファレンスのその。
いやエディットだもん。だってエディティングシステムについて聞いたんだからこっちがこういうふうに同時に多分この人はこっちに動かしたいこの人はこっちに動かしたいって時にどうするのってそれでもうできるとかって言っちゃってるからでも2つ要するにもうイメージからすると2つできるのかなと思ったのそういうことなの？
そういうことじゃない。
それはもう彼はそれでもファンタスティックこれがこういうMのなんとかってやつあったでしょなんかやばいとか言ってたあれが れバッグとかは
バッグそこに貴重品だけちょっと。
individuals. Let's see if we can figure this out. So what do you have, USB presumably?
Yeah, yes.
Did you already try plugging it in?
No, because I saw another USB slot. I'm gonna try this one.
Let's see what happens. I'm very much, when it comes to technology, let's just give it a shot and hope it doesn't blow
It
up on
works.
us. Okay. I'll be back in just a second.
Okay, thank you.
You're the first presenter, aren't you?
Yeah.
Did you already give your presentation?
Yeah, please give the base copy of my file to the desktop.
Okay, fine. Oh, are you gonna present? Yeah. Oh, cool.
Sorry, just so which one is you?
I'm the second one, Henrik.
Are you gonna put the file on our computer?
Yes, please.
Cool. This one?
Exactly.
Do you have videos inside?
Yes, but well, I don't need sound. Actually, it would be good if we turn off the sound.
Oh, I see. Yeah.
This is
Is
the.
this the
Oh, can I start it? Just. Okay, and then I can turn off the sound there.
Yeah, it's already turned off
Oh,
from the
perfect.
console.
Okay.
That's fine. All good.
Thanks a lot.
Thanks.
Oh, I got a presenter. Is that? Or
We
or
don't
do I
have
just-
a clicker, so you have to press the keyboard or use the mouse. Yeah.
Well, I do, but okay,
Oh, you
but
have it.
I can actually use the mouse. That's fine.
Oh,
So-
if you want to use the clicker, you just connect the USB to here.
Okay.
Yeah.
Right. Thanks a lot.
Oh, good. Hi.
I'm
are you-
Steve, by the way.
Oh, cool. Are you the chair?
Yes.
Oh, yeah. My name is Shisha.
Shisha, nice to
Yes.
meet you.
Cool.
So, is everyone set up in terms
Oh,
of
only
presentation?
one person is.
Okay.
Yeah, we're staying three.
One more, and that's lucky.
Oh, really? Is this your file?
Yeah.
Oh, cool. Sorry, which one is your? The first one?
Yeah.
Oh,
You're
cool.
Steve.
I am.
Hi, I'm Henrik.
Hi,
I'm
Henrik.
the second presenter.
Excellent, nice to meet you. And you're presenting alone, or have you got a co-collaborator?
Well, my boss is here, but
But
I'll
he's
be
not
presenting.
Excellent, I'll just introduce you then, just want to make sure.
Thanks a lot.
You are, how about I get on the right side? You are Henrik.
Yeah.
Excellent, thanks Henrik. Lucky for you, it's just you presenting, and a collaborator co-presenting, or just you, or is this different? Okay, sounds good.
So, do you need a reminder of time?
Yeah, could we?
Yeah,
If you have a collab, that way I'm actually just gonna listen,
Right,
and I'll
right,
try to
right,
kind of
yeah.
come up with some
No
good
problem,
questions,
yeah.
if you can have time to be one.
So I will give a hint when time reaches 15 minutes.
Okay.
Yeah, cool. So
Sounds
yeah, we have 5 minutes for Q&A.
Okay,
Yeah.
sounds good.
Yeah.
And you're giving that to the presenter, you hold up 5 or something like that?
I don't really have a board saying 5, but
Oh, even better, that's perfect.
I might just like tell them whenever I raise the card. It's just 5 minutes away.
I mean, I can have them show up, okay?
Yeah, because lots of prisoners actually they go really fast. Yeah, they go before that.
Well, this is, I don't know how many of these conferences you've been involved with, This is actually a little longer than they typically are.
Oh, really?
That's a nice thing, actually.
Yeah.
It allows for a little more relaxed pace
Oh,
where we can have the
cool.
discussion. But I think for some conferences, I mean, we're trying to hit 10-minute presentations.
that's
for
too
some.
tight, I
It's
guess.
very quick, yeah.
Yeah.
And so you may have some people that weren't sure exact lengths. So
Right.
that may be part of why they're finishing quickly.
Right, I see. Yeah. It's nice to have some extra time.
I agree. I mean, I tend to think at these things, the networking is really one of the biggest values, but I think also the questions after, it's
Yeah,
really helpful to see, you know, to the rest of the community, what is either something that's not clear or limitation or opportunity.
totally.
So,
Yeah.
so are you a student or what are you doing?
I'm doing architecture. So
Architecture.
currently I'm graduating my 5th year. So
Okay.
last year the masters.
Good.
Yeah. Our school just across the road.
So what are you going to do after you graduate?
I'm currently applying for just normal architecture graduate jobs.
Okay.
Yeah. But this year I did the thesis on VR and architecture.
Okay.
So it's like a combination. We want to combine physical architecture and VR.
Okay.
So when you wear the headset, you can actually feel, like touch some parts of the building.
Okay.
Yeah, so that's
Sort of the tactile or haptic
yeah,
kind of.
tactile VR.
Yeah, makes sense.
Mm. But I mean, like the technology is really not ready yet. Because sometimes like we have drifting issues all the time,
Yeah.
and it's just not picking up the right location for objects.
Yeah. So I'm actually looking at something it's not really design what you get, but it is something with haptic I'm interested in.
Mm.
And I believe there are opportunities for it, but I also wonder if we're going to have a paradoxical effect that sometimes the more information or more detail you provide to a user, the more able they are to see why it's fake or that it's fake. You know?
Yeah, totally.
Almost, you know, when you were a little kid and you played Super Mario or something, it was super basic, and it was enough to say, I get it.
Yeah.
Now as video games have gotten better, you say, well, the grass doesn't really blow the way it should. Or what.
Sometimes you have to give user the imagination.
That's right.
Yeah, you
Yeah.
can't just. Yeah.
And so I could see something like that happening with some of these haptic sensors. If they're good but not perfect, then you know, we may get, who knows.
Yeah, it's tricky.
And so we've got 2 before uploaded, is that right? Or did you
Yeah,
say
we
you
only
have-
have 2. We're still missing the other last 2.
Okay. Well, at least I've seen yesterday both of these individuals from the 4th one, so they're at
Oh,
least
cool.
here. I don't think I know, I'm not sure if I know
The
the
third one, yeah. Just what time is it now? Yeah, we still have a few minutes. Hey, are you presenting?
Next session.
So the third one or the fourth one?
This one. This one.
Oh, the next session.
This session.
Oh.
So here do they have the USB?
Well, we have USB, and you can also plug in your computer. Yeah, but you can wait for a few just for the next session.
Okay, yeah, indeed. If there's a next one.
Oh, we don't have a clicker. Sorry, you have to use the keyboard or the mouse. So you just press down or up. Yeah. It's pretty straightforward.
Flash?
Flash. So you want to play some Flash videos?
No, just to transform the file. before.
Oh yeah, we have. I have a USB drive, so
Yeah,
I
can
can.
you? Yeah, or maybe you will be you will also be here.
Yeah, I
next
will be
session.
here the entire
Okay,
day.
Yeah.
Yeah.
Later.
So are you from New Zealand or?
No, it's my first time here.
Oh, right.
I'm from Arizona State University.
Oh, right, the States.
So
Oh,
yeah,
cool.
first time.
Welcome.
Thank you. Beautiful, beautiful country.
Today is just like this. 2 days out the weather's.
Yeah.
Just,
Yesterday was nice. I don't know. Did
Yeah.
you go out for the dinner?
Yeah, I was
That
there.
was pretty gorgeous
Yeah,
evening,
yeah.
so that was really nice.
It was like a perfect day.
Yeah, absolutely. So yeah, it's been a great trip.
Yeah. It's a nice season to travel to New Zealand. It's just summer, everything's great.
Yeah. Well, and for a lot of the states right now, it's getting very cold.
Oh,
So
yeah,
this is
yeah,
a nice
northern
kind of
hemisphere.
break. Yeah, yeah.
So are you guys gonna stay here for long, like for a few more days?
So I mean for another day, but until Sunday.
All right.
I got here though last Saturday, so I had a couple days beforehand to go explore a little
Oh,
bit,
that's
you
cool.
know, see
That's
the
cool.
Waitamo Caves and some
Oh,
of these
right,
kind of
right. Oh,
touristy
that's not bad.
stuff.
Yeah,
so it
yeah,
was
yeah,
fun.
yeah. Today's Black Friday. Black Friday.
Yeah.
Yeah, yeah. Just can't go shopping.
So if we have our For the others to
Because
join? It's
for
right after lunch, so I don't know.
yeah, for some previous sessions, some people come late and we just plug in their files right before their presentation.
Okay. And what is the plan if someone doesn't show up? Do we wait or do we just present at the next one? Because I've been at conferences that do both, so I don't know.
I haven't encountered that one, but maybe we just move forward to the next one.
So move the next one early?
Yeah,
Okay.
yeah. And,
I've seen it done both ways. I mean, you can do that, then it's good for the people that are here, but if someone was hoping to come to the other side, they're gonna miss it, so.
Yeah, true. I'm not 100% sure about that one because I wasn't told like anyone is missing.
Okay.
So, yeah.
Well, hopefully they're not, but I just
Yeah.
figured it's probably worth going over in case someone didn't, so.
Yeah, true. Oh, it's my turn.
If you want, we can just go on to the next one if they're not here. Fortunately, the first two are here anyways.
Yeah, so we can maybe start right now. Overview, this is the first one. Yeah.
Should we start?
Yeah, we can start.
Sounds good. Lucky, are you good to go? Okay. All right, good afternoon, everyone. My name is Stephen Ayer. I'm going to be the moderator for this session here. For all the presenters we've got 4 in this session. Hopefully, I think 2 of them have their content already loaded, and 2 more should be joining us shortly. Like the others, try to keep your presentations, if you would, to about 15 minutes. You get a warning when we get close to the end, then we'll have some time for questions at the end. So with that, our first presentation is going to be by Mr. Lucky Pratama from University of Washington, and his work is entitled An Overview of Generating VR Models for Disaster Zone Reconstruction Using Drone Footage. So with that, Lucky, the floor is yours.
All right, thank you, Steve. So good afternoon, everyone. Today I would like to present the result of my research, which I conducted with my friend, Mohammad Sadra Farhosseini, who is also a PhD student at the University of Washington. We work under the direction and supervision of Professor Ken Yulin, who is an associate professor of the Department of Construction Management at the University of Washington. So before we begin, I would like to introduce you to our background of research. We don't know when disaster is going to hit or how strong it is, especially if it is earthquake. We can only predict the time frame it's going to happen and the range of the strength of the earthquake itself, but we can't predict how strong it is. And we can also predict when exactly it's going to happen. So whenever a disaster hits us, it will leave trails of wreckage, especially infrastructure and buildings. And for this research, we would like to focus more on the building side of it because we feel like that is where our research will have any impact on it. And of course, after the breakage occurred, there will be recovery efforts, mainly in the building reconstruction. And the process of the reconstruction itself will expose everyone to hazard. I would like to relate this to my experience about 10 years ago when I was in Indonesia when an earthquake hits my town. So a lot of building was damaged at that time. And the National Disaster Mitigation Agency of Indonesia recruited several students, and there were a lot of students that participated, and then they were given a task to investigate and inspect any damaged buildings to determine whether the building is still safe or not. And this happens before any construction is going on. So this happens like 1 or 2 weeks after the disaster hits the town. And we had to enter the buildings, and we were not aware about any of the risks or any of the hazards that were present inside the building. So essentially, we are risking ourselves to go inside the building, and anything could happen. Well, thankfully, nothing happened, but still, there is the hazard that we have to be aware of. So based on that experience, we would like to propose a system that can be tailored based on the time and location of the disaster that can be useful to train the workers or anyone who works in the disaster area or the disaster site. So So we conducted several literature reviews, and we found that VR, AR, photogrammetry, and laser scanning has been studied extensively in regards to disaster mitigation and recovery. So we found that photogrammetry can be used for augmented reality application for building structural evaluation, and aerial photogrammetry can be used to assess a damage of an area, and also it can be used as a reference for a post-disaster reconstruction plan. And our goal with the study is to visually assess how detailed a photogrammetry model can be generated from a video to provide an overview of assets creation for disaster training tool and to assess the viability of the photogrammetry model for use in virtual reality environment. And lastly, to propose a system that can be deployed for evaluation of workers' risk awareness before entering a disaster area or disaster site. So what we are proposing is a VR system that is potential for using the model, that is potential to evaluate the workers' hazard awareness. The system itself can be used to easily measure the workers' attention before entering the disaster site. The system has to be customizable depending on the location of the disaster itself. And the system must be able to be prepared quickly in a short time, because whenever a disaster hit, we would like the environment of the system to reflect the actual environment on the disaster area. So why did we use VR and photogrammetry? So unlike AR and mixed reality, virtual reality can immerse the user into a different environment, whereas AR puts an object on a screen, and MR is like combination of AR and VR. They don't really bring in a real immersion to the user. And also photogrammetry can be used for rapid generation of the disaster area, as has been pointed by previous presentation. And next thing is drones can be deployed to acquire the images or footage needed to produce a model of the disaster area. So the thing with doing photogrammetry is you have to go to the site and take photos manually. And that itself can be rendered useless because you have to go inside the building and take photos. Might as well do the evaluation right there. So our idea is to get a drone and put the drone inside the building and manually control the drone while the drone itself is capturing the footage of the building. We feel that it's more financially viable for us and faster, because we didn't have to mount any kind of laser scanning or setting a path for the drone, because we don't know the layout of the building when we are capturing the photos needed for reconstruction of the model. So we acquired a video from the internet with the permission of the owner, Louis Wild, who captured this in Philippines in 2014 after a typhoon hit the area. And the video resolution is pretty good. It was captured in HD, 1920 by 1080p, and recorded at 60 frames per second. So we extracted the images at 2 frames per second in order to get a lot of image needed to reconstruct the 3D model. So once we extracted the image, we put the image in a photogrammetry tool. In this case, we use PhotoScan, which is quite affordable for us. And then we align the photos using software algorithm to generate a sparse point cloud data. And then we validate the path generated by this PhotoScan with the actual drone footage. So as you can see here, these blue squares are the path that the drone took when when capturing the footage. And after that, we generate the dense point cloud based on the sparse point cloud, and then we convert into mesh and texture the model. And after that, we decimate the model so that we can get adequate performance when we are presenting in virtual reality. And after that, we bring it to Unreal Engine 4 so we can present it in virtual reality. And as you can see in the picture, there are 3 videos. On the top left is the original footage of the drone, and the top right is the original mesh we generated in PhotoScan, and the lower left is the mesh that we put in virtual reality. As you can see, the texture resolution for the VR model is considerably lower when compared with the original model, and it also lost some fidelity, and there's also some noise on the surface. However, with the lower fidelity, the model is still recognizable, and we think it is still viable for use in virtual reality applications. So now we have the model. What are we going to do with it afterwards? So we have the idea of using heat map to evaluate whether the person using the virtual reality really paying attention to any hazards that is present in the disaster site. So we achieve the heat map function in Unreal Engine 4's blueprint. Essentially, we draw a straight line from the virtual camera, and whenever the line hits a mesh, it will increase the value of the texture. It will increase the color value of the texture. So whenever a person is looking at an object, the object will gradually change from a neutral color. In this case, we use blue, and then it will change to yellow, and then red and red. And this is the result. So we think that the heat map can be used to evaluate whether workers or inspection team members pay attention towards the hazard. So in theory, more attention is indicated when a person looks more frequently at an object. But this is something that we are going to do in our future research in the next phase of this research. And from our study, we found several benefits and challenges of using photogrammetry and VR for evaluating the workers and trainers' attention. So first, in terms of the photogrammetry object, we can quickly deploy it into the system because the model can be generated rapidly within a few hours instead of modeling it in 3D modeling tool such as 3D Studio Max or Revit. And the original footage can be used for other purposes. It should be noted that we use drone footage instead of taking photos from the drone. So if we are just capturing images, those images will be used solely for reconstructing the 3D model. But if we take footage, that footage can be used for other purposes that is not strictly related to the disaster reconstruction or something else. So it can also be used for a quick evaluation system for people working in disaster site. However, there are several challenges. First, there's no guarantee that the model will always be good, because in this case, we're going to put a drone without knowing exactly the layout of the interior of the building. So when we capture the footage, we might not be able to cover the entire area. So there might be a lot of holes when we generate the models. And also, the models, when poorly optimized, could cause bad performance. And also, we experienced some texture incompatibility with the 3D modeling tool, and it caused us additional work. We had to do some retopology of the 3D model. And the conclusion, even though photogrammetry is not as sophisticated as laser scanning, it can still be used to generate a viable model if automation is involved. In this case, using the drone during the image acquisition process. Also, it can be used. It can be more efficient to capture footage if we would like to do this rapidly. And VR and AR implementation can be done to allow visual assessment or as a workers training module. So that is the presentation of my research. If you will have a question, feel free to ask me.
think we've got time for a couple questions, if anyone has any?
Yes?
Okay, so I'm confused a little bit. So you have, so are you training first responders, or are we doing something else?
So training the first responders is going to be the next phase of the research. So at this point, we are creating a tool to train those first responders or anyone who is going to work in the construction site in this area.
Disaster, so that's much more sense. I think this is good and novel approach. I think if you can use the footage to do damage assessment automatically, that'll be a lot more substantial, because the issue is not really, I mean, if you can fly a drone, you can look inside and do damage assessment as well. Now, there's safety issues, I get that, but in most disasters, the damage pattern will be relatively similar. And if you are a structural engineer who knows what an earthquake damage looks like, you are the person who makes a decision whether someone should go inside or not. Now, the drones can be useful, of course, I mean, so you don't go inside, but the VR AR part is a little bit shaky for me, because if you can use image processing or capture some knowledge from the footage, I think maybe classifying damage, because that's a huge area that people struggle with the damage assessment. Not necessarily how to do, damage assessment, but how good the quality is. Because you as a student probably should not have done disaster damage assessment. You should be a structural engineer at that time. That's just a comment.
Okay. Yeah.
Did you do any comparisons between having the model and just assessing from the pictures? And if so, what are the metrics that you used?
We haven't really done that comparison yet.
What type of computational capability do you need to put the model together? Is it a pretty substantial computer or cloud-based?
Well, I use my laptop for that. Yeah.
Any others? Got one other, sort of based on the comment that we had heard earlier. It sounds like you're using this for training of the individuals who, whose home it is or something like that that may be related to that space. Do you think there's an opportunity to leverage experts who may not be local and use this as a way of gaining that expertise from someone who may be across the world or wherever, using your interface to get that expertise from someone who can't be there but to inform the others, as opposed to having, say, first responders or laypersons wear it for on-site? I'm curious if that's in the plans.
We haven't planned that yet, but yeah, but as what's your name?
It was good.
It's good.
It was good.
All right.
Just so that.
As pointed by the gentleman over there, there's. I think it's more viable if we use like image recognition or artificial intelligence to analyze the footage for those people who are not in the location, rather than having them put on the VR glasses, pure goggles to assess the damage individually. But
I mean, just thinking aloud, I think this is really cool for that purpose, and maybe even for something like insurance claims. Something like that, if I've got damage and I want to get a claim on my house or something like that, and I don't have to have an insurance person come out to survey damage, it would be interesting to at least see what their thoughts are on it, because I suspect some of them would be intrigued with the kind of model you're developing.
Okay. Yeah, that might be, we might consider that for our future research. Thank you.
Sounds great. Thanks so much, Lucky. Let's thank you. All right, so next we've got, actually I'll pause quickly and just check. Do we have other presenters for the next two that we've got? Anyone else in the room? Either Hungmin Chen?
Just plug it in, right?
Oh, yeah. No? Or Wen Zheng? Okay, hopefully they'll join us momentarily. So our next presentation that we've got Heinrich Schroeder here, who's going to be presenting his work on a didactical approach for the training with virtual reality. So with that, Heinrich, the floor is yours.
All right, thanks. So, yeah, I'm Heinrich, and I did this paper together with my senior engineer, Dr. Friedelmelt. The topic is a didactical approach for the training of virtual reality, and this is what I would like to talk about today. First of all, I would like to give a little introduction. So what is the problem that I'm actually going to solve, or which I'm going to partially solve? I'm going to explain what the target is of the paper, and I will then derive a theoretical concept. This concept will include what the software should look like that I later programmed. I'll give you a little video of the software, and then last but not least, I'll give you the results of the experiments I did with the software and just show you what the benefits are. So, the introduction. So, we're from Germany, and in German construction industry at the moment, we have a very high amount of seasonal workers. So by definition, these seasonal workers do not have the same experience as a full-time employee of a company. And so they are rather low qualified in comparison with other fully employed persons. And this kind of leads to a high demand for the qualification. So basically what we're doing right now is that supervisors or more experienced worker work together with a trainee and show them how it's done. This results either in the supervisor has less time to do his own work, or if he does not spend that much time in supervising, the trainee will make mistakes or he will even hurt himself. So, and then at the same time we had several presentations today and yesterday. We have virtual reality, which is kind of a promising technology. And we could use that for training assembly tasks in this construction industry. So this paper is not yet about comparing other technologies. We did that in later future works. It's just about getting to know of how software for these kind of trainings should look like. But at the moment, there are virtual reality trainings for these tasks. But the problem is that whenever you have a new task that comes in, basically what people do is they do completely new programming. And we want to avoid that. So we want to take down the costs, take down the time to initiate such a training by implementing a software that can be taught the scenario fully immersive and without programming knowledge. Then usually if there are some software for this purpose, they do not have a very clear didactical approach. And if they do have, they are normally not quantified. So what is the target of this paper? I want to establish a VR training concept for the cognitive aspects of assembly tasks in construction industry. That training concept should require only a reasonable effort, meaning that I do not want a programmer to do a new training setup only because I have new CAD data or new BIM data. Secondly, it needs to be adaptive, meaning that if there's a trainee that is more experienced than another one, I want him to get a harder training. And third and fourth, the software or the concept should be tested and it should be quantified. So this is basically what I'm going to do. For the theoretical concept, basically I do two things. First of all, I'll define the learning sequence, which I would like to improve later. And then I'm going to derive some didactical principles that I put on the sequence and derive some of the concept of how the software should look like. Okay, so for the learning process, what I understand in this paper as the learning sequence that I would like to teach with VR. First of all, the worker receives any kind of information that can be orally, that can be written, but it's usually some kind of information like move a part A in a place A to a part B. Then the second step is that the worker identifies the component wherever it is. Then he identifies the final position, and last step is he executes it. So that is one sequence, and usually the training scenario is set up with multiple sequences that have to be memorized. So how is that implemented in a standard VR approach if you do not have any programmers available? You have to give him some kind of information, okay? So the easiest part is just to put in a list with written instructions. No programming involved, no big deal. Secondly, you leave the worker alone and he is searching for the part. He's searching for the final position and he's then executing the step without getting any feedback, because feedback would have to be programmed. So this is basically the standard approach that I compare my own approach to. So later when we see the results, this is what I call the standard approach or the opposing concept. So now I got my approach. This is based on a prototype that I actually explained in an earlier paper. But the basic concept is that we have a trainer come in the virtual reality, and he is basically executing the entire training sequence one time. And the software records anything it needs. Meaning it needs the part, the tool, the final position, original position, or even hints or warning signs, whatever it needs for this training session. And then when the worker or the trainee when it's the turn of the trainee, he gets all these information whenever it's needed. So for this paper now, I have enhanced this concept by this, what I call the didactical approach, with 5 levels. Actually, it's just 3, because level 0 is more like a presentation mode. It's not very active. It's more, people can put on the VR glasses and just animate anything, can just get a glimpse of what it's like. It's not really training. And level 4 is not really training either. It's more evaluation. So it's the final test whether the trainee understood or did not understand the training. So I already said level 0, that is basically animating a part whenever I press a button. Level 1, the training starts to be a little more active, meaning that the trainee gets all the information he needs. In this case, the easiest part. Usually this is indicated by blinking of the part that has to be moved, and a shadow of this part blinking wherever it has to be moved to the final place. The tool that has to be used is usually placed in the hand of the trainee, so all the trainee has to do is move the part. Then it gets a little trickier. The identification of the component is not supported by the software any longer, meaning that this is some information that now the trainee has to know. So basically he has to memorize what part do I have to move. But the rest, the tool and the final position is still indicated. And then level 3, this is the hardest part. Neither the tool nor the part nor the final position is indicated, meaning that by now the trainee should have memorized everything. We still have some kind of control mechanism in place. That means that once the trainee grabbed the part, moved it close to the final position, there's a little threshold that I find the object will snap in, so that I avoid these tricky things that is not really part of the training task to place virtual objects where it belongs, but it has to be close. Yeah, so that is how the software is supposed to look like. And yeah, just to make it easier to imagine, I have this little video. This is just level 1, 2, and 3. And this is, yeah, with the Lego. So this, I'll explain later. This is level 1, so you see both parts are blinking. Not very hard. Level 2, it's just the final position that is blinking. The tool is always the standard controller. And level 3, neither one is blinking, neither the final nor the original position, but you see the object is snapping in, so we don't have to do fine adjustment as a training. This scenario is just for demonstration, so of course this is not a real working task of construction industry. But this brings me to my evaluation. I have derived the concept, I've put it into software, and I want to put it into action. And I had kind of the problem that if I go into real construction tasks, it either gets too expensive to repeat the training, it gets too dangerous for the trainee, or we didn't even have the material to do the training. So since I only focused on the cognitive aspects of this training, what I did is I took these plastic Lego bricks, and then I'll carry out the experiment with these 2 scenarios, and then later derive or hope that I can take these results to the reality. So what is the question of the experiment? It's the one and only question: does the new approach offer any benefits? Again, this is in comparison with the VR standard approach that I explained earlier. The procedure. We have 2 scenarios, scenario 1 and scenario 2, that are equally hard for the trainee. that have to be memorized. And we have two groups. Each group is getting one scenario and have to set it up for 3 times in the virtual reality. Meaning with the VR standard approach, they have 3 times to build it. Meaning with the new My approach, we have level 1, 2, and 3. While doing so, the trainee may take as much time as he likes. And whenever he says stop, that's it. Okay, so no time pressure here. And after he's done in virtual reality, he goes back into reality and shows me whether he has learned or whether he did not. So he's actually building these 2 scenarios. The measurements that I took is, first of all, the duration of the training, defined by the trainee. Then, after the experiments, I asked the students to grade my software and the other software. And these are the ones that I found significant effects on. So these are the ones I'll go into detail in the next 2 slides. And the other 2 measurements, I took the duration of the execution in real life, and the mistakes made in real life did not show any effects. So basically they were the same. Not the same, not really the same, but close enough to be same. So for the evaluation, on the y-axis you can see the duration of the training in seconds, and on the x-axis the participants. So as you can see, we have a number of 10 participants. The darker bar is the standard concept, the opposing VR concept, and the lighter one is the training time with my concept. As you can see, the average dropped from 710 seconds to 256 seconds in the training time, which indicates that there's a good effect. I did a paired one-tailed t-test with an alpha of 0.05, resulting in a critical value of 1.83 and a t-statistic of 8.68, which leads to, or which now I may conclude that with a 95% probability, we do have a significant effect when using the, my concept contrary to the opposing concept. For the motivation, again, on the y-axis you can see the grading points. It's a scale from 0 to 15 points max. On the darker columns are, again, the opposing concept. The lighter one is mine. So you can see that the motivation when using my concept rose from 5.2 to 12.4 points. Again, I did a paired one-tailed t-test with an alpha of 0.05. Critical value again is 1.83, and the t-statistic in this test is 6.9, which again leads to the conclusion that with a 95% probability, we do have a significant effect when using my concept. So what are the benefits of this paper? First of all, I do have a standardized approach that I now can optimize. And it's an approach that does not require any additional effort to be taken into action. So still, I don't have any programming. I still have just the trainer who is setting up such a training within minutes usually. And yeah, no other knowledge, and I can just put in new BIM data, new CAD data. The training time of this concept is significantly reduced. The motivation is significantly increased without affecting the other target values. So the outlook or the future steps, the future works. When I did this paper, I didn't do the experiments with competing technologies. We did that by now. So we had further experiments with this software in cooperation with Mercedes-Benz, a German car manufacturer. We used augmented reality. We used a self-programmed desktop app and also a mock-up and compared training times, again with pretty impressive results. And of course, we want to applicate this software in further industrial use cases. So that's basically my presentation. Thank you for your attention.
Would anyone like to open up with some questions?
I'm wondering for the training times, is that for the 3 times summed up, or is it an average?
No, that is summed up. So we did some measurements where we were observing how much time the participants were taking for each level, but they're not really impressive results, so just random.
So for the because I'm interested in the standard VR approach.
Yeah.
I would assume that time went significantly down if I'm repeating the exact same training 3 times.
You
So
mean?
my
Oh, okay, I see what you mean. Actually, we didn't really look into these numbers, but like I think you were right. But actually, what matters in the end is the total training time. So really, like the distribution within the training time doesn't matter to me as a company. So yeah, but you're right.
So I'm curious, I mean, clearly the model that you've got at the moment is to prove the concept of the process. And I think you even alluded to that. This is really to illustrate the underlying aim of your work. Could you talk though about, in a year or whenever you see applying this to construction tasks, what types of construction tasks do you see as being the real opportunity areas for using something like this beyond just kind of the simple model that you started with?
Okay, this may be any kind of construction task like a scaffold, for example. You may think about complex bricks industry wall. Okay, this is my English. This wall constructs. I'm not sure what they are called in English, but whenever you have some kind of construction that is modularized and that needs to have some kind of setup. Okay, so yeah, whenever it's about security reasons, so these are the tasks that can apply.
And do you envision using this when you have customized different instances of that, or do you see it doing for one type of scaffold and someone applies the same general type of thing?
The first one, because like the whole thing is that I can just put in a new database, a new CAD data, and set it up again. So otherwise, if we had one CAD data for several training purposes, I could put in much more effort and program the thing, make it much more fancy, sexy, and probably get even better results. But this is just if I have the time of putting in the effort.
Yeah.
Like for just one case, I wouldn't ever put in the effort.
Part of where I was going with that is if that's the case, do you have a vision of maybe using something like this of the training rather than a human, using something like a 4D model? It's just far more detailed than we're used to doing in 4D to almost automatically populate some of that?
Sorry.
Do you know what I mean? When we say 4D model of linking a schedule to our model and showing how the construction goes up over time, what I've typically seen is entire segments of walls going up at once.
Yeah.
But you could envision designing a 4D differently that shows individual pieces going in.
Yeah.
And could we use that to train your system?
Probably, yes. So for this work, I have defined a very own format that is defined by the software, but actually what is important is what kind of information goes in there, and I think this is pretty much the same information. You have some kind of order in which the steps have to be worked. You have the parts, you have the tools, so yeah, basically you should probably have to do the link for the format, for the programming, but then there shouldn't be a problem.
Cool. This could be good for a workforce and helping people understand what they're being asked to do, especially if they're newer to construction, which is certainly a timely problem to be targeting. Any other quick questions on this? Yes, please.
Thank you for the presentation. Just want to have the training is one person.
Yeah.
Is there any thought about collaboration with them?
Not yet. Well, for this part, for this assembling part, I did not really think about it because memorizing stuff is usually something you do for yourself. There's another aspect of the software that I didn't present here, which is more about security reasons, but not that much in construction industry, more in industrial or like in machinery building. What they did is that actually there was just one person with VR glasses, and the other ones were watching over the mirror, and they were starting to discuss and trying to find mistakes in the machinery that could be an open knife, for example, some kind of dangerous aspects. And, but this is actually a completely different part of training because you have much more time to like pre-work or preparate such a scene in virtual reality.
Because that could be interesting to see if you have two persons working on the same has the potential to have different learning curve. So
Yeah.
maybe one will go faster than the other.
Yeah.
How can you actually manage inside your hands to put the two persons at the same level?
Yeah. Might be an interesting idea also, from my experience, when people try to communicate, this might enhance the training effect, because working in a group might be better. I didn't think about it yet, but thank you.
Thank you so much, Henry. So I'll just give a quick double check before I move on one here. For our next presentation, is either Hungmin Chen or Shenghan Hu here? Sometimes this happens towards the end of conferences, travel schedules, they may have had to duck out early. If that's the case, we're going to move on then to Jun's presentation, Jun Wang's presentation. So our next paper will be titled A Framework for Vision-Based Automatic Scaffolding Productivity Analysis. And this paper will be presented by Jun Wang.
Yeah, thank you. Good afternoon, everyone. I'm Jun Wang from Curtin University, Australia. This paper comes from a PhD student's first year study. And we aim to develop a vision-based automatic approach to measure the scaffold productivity. So why we choose scaffold? I think the first easy reason is because this research project is sponsored by a scaffold vendor named Kifa. The second key reason, I think, is the importance of the scaffold in oil and gas industry. So in Western Australia, there is a huge demand of scaffold at both construction and the maintenance stages. So just give you an example, in a typical, I think the major plant shutdown project, the overall duration is around 28 days. And each day will cost $2 to $3 million. So you can guess how many days needed to erect and dismantling this scaffold. 6 to 7 days. Yeah, so the client said if your team could save 1 or 2 days, they can save lots of money. Well, so indeed, in the last 2 or 3 years, our team had developed several innovative solutions. Like we use BIM to improve the scaffold design. For example, they already have the 3D plant model. So if they want to replace this pump, they just click this pump and select a specific scaffold type, and then the scaffold will be automatically generated, and also the quantities. Yeah. So we develop a very detailed 4D BIM simulation to help the site workers to know how to erect this scaffold, yeah, safely and efficiently. And also, even we create some visual work package, so the site supervisors and also the workers can follow the schedules, to improve the productivity. But I think the clients still want to know what happened on site and what's the real productivity of the scaffold workers. So, and also I think another reason is why we choose scaffold is the high cost. So I can give you 2 numbers. So the hourly rate of a scaffold worker, on-site scaffold worker in Australia is around 120 Australian dollars. 120 Australian dollars. So for research staff with a PhD degree, in university, is around 50 Australian dollars. So sometimes, I want to resign my current job. I want to work as a scaffolder, because I can, get more money. Yeah. So, yeah. So let's look at the current method for measuring the scaffold productivity. So they will employ a third person, on site to watch and to record the time. of the site workers to erect and dismantle the scaffold. So we know it's manually and time-consuming, inefficient, and also not accurate enough. So in this research, we try to use, we try to leverage the current videos, try to develop algorithm which can help us to recognize the posture of the scaffold workers and also automatically calculate the productivity for the clients. These four are the currently, I think, the popular method used for activity capturing. We choose the final one. I think the key reason is the final one is very easy to be implemented on site. So sometimes maybe from the academic perspective, they want to improve the method as accurate as possible, like even 100% is accurate. But for the industry partners, for the industry people, sometimes they can sacrifice the accuracy. If one method can be very easy to be installed on site. So that's why we choose the video, the CCTV. This slide shows the whole idea. So these on-site videos will be firstly imported into the video processing platform. So this platform is developed based on open source toolkit. Someone had already invented that. So it's named OpenPose. So we use this one as a basis. And then I think after the video processing platform, we can get the 3D vector of the human postures. So our focus is not the algorithm. Maybe in the future we will use another open source toolkit if that one is more accurate than this one. So our job is to do the activity definition and classification. Because from a lean perspective, the activity can be divided into three categories, like the value-adding activity, non-value adding activity but necessary, and the waste. So for scaffold construction, I think the fixed coupler is the value adding activity, and the component moving, like you move the tube, is the non-value adding but necessary, and the searching component. If you want to find where is the component, and also you're just waiting for the materials. I think that one is the waste, non-value adding activity. So following this protocol, I think the activity in this research is classified into effective activity, the contributive activity, and also the ineffective activity. So we try to use the different classification method like the SVM and the KNN to classify the 3D vectors. So this slide shows our current progress. I think right now we can only successfully recognize one type of effective activity. I think the fixed coupler, only this type of action. So in the future, we will try to continually improve our classification algorithm and also try to recognize the other two types of activities so that we can calculate the productivity. So in terms of productivity measurement, there are two types of approaches. The first one is based on time. So if we can have the time of the effective activity and the contributive activity, we can add these two and divide it by the total duration. The second approach is about I think it's calculated based on the quantity. So how many numbers of couplers or scaffold installed in a specific time t, and then we can calculate the scaffold. So we don't know which one is best because we still need to discuss with our industry partner. And we don't have a conclusion in this slide because we put that part, I think, in the next year conveyor. So feel free to attend the next year conveyor, and we can share you more information about that. So yeah, that's all. Thank you.
Anyone have any questions? So I'm curious, you said you're working with a scaffolding company.
Yes.
I think was pushing this forward. I'm curious, what did they approach you with in terms of the problem they were trying to solve? And I'm curious also how they're using this in their organization. Maybe you could talk a little about how they're using this and what their underlying issue was.
I think first is because we had got a big grant, from the Australian government. So it's a scaffold topic. So I think they saw that news, and then they are very interested in investing some money in this issue. So they come to visit our lab, and we show our preliminary result. So and then they say, okay, maybe this part is more interested. So they give us this topic and ask us to investigate some innovative method, to do the productivity measurement. Yeah. So. What's the other question?
So I guess then the other part of why I'm asking about how they're using this is it almost sounds like on its surface this would be something that a general contractor would be especially interested in, because if they're paying for people to erect scaffolding, it would almost seem of more interest to the general contractor or the construction teams than the scaffolding companies. So that's why I guess I was curious to see how are the scaffolding companies aiming to use this? Is it in designing new types of scaffolding to increase productivity, or what have you seen as the way that they're using this?
Okay, I think for this one, first the client wants to use it. Yeah, because the client pays the bill with the scaffold, and so they want to reduce the duration because they rent the scaffold. And for the contractor, because they pay the human cost, the labor cost, so they also want to improve the productivity. So that's why the big research project. So we have the client on board and also the contractor on board, even the scaffold supplier. Yeah, because they want to work together to improve the whole scaffold life cycle performance. Yeah.
Makes sense.
Yeah.
Any others? Yeah.
Can you use the video, so since you're already taking video and you're tracking, does it predict or count unsafe behavior for safety training for scaffolding? Can you recognize unsafe acts during the scaffolding?
Yeah, I think so, because I think yesterday some researchers they presented they use the same technology to recognize the posture, and then they try to analyze to recognize which behavior is safer, which one is not safer. I think there are researchers doing that part. Yeah, but we are not focused on that part. Yeah.
Any others? One quick other question on this.
Yep.
How expandable do you see this being to other systems outside of scaffolding? Because you've done a lot of work to track the behaviors. Do you think you can apply this relatively easy to other systems as well?
Yeah. I think for this research we target on the scaffold productivity. Yeah, but I think we can use the same method for the rebar, rebar erection, and also the other construction activities. I think so. Yeah.
All right. Thank you.
All right.
Thank you so
Thank you.
much, Jun.
Thank you.
So before we close out, I'll make one final check. I just want to make sure, is it Hungmin Chan or Shanghan Hu here? Looks like we'll all get about 15 or 20 minutes back to our schedule, so if you'd like to join the other session, you can, or can hang out for some coffee outside. Let's one more time just thank all of our presenters for all of them for presenting. Thank you. Thanks, everyone. here's the challenge, is the more prescriptive you get, the better it is for the user, but the harder it is for the trainer. Even if it's easy, because it still requires more scenarios to go through. The less prescriptive you get on the task, the more sophisticated you are, the better it is for the trainer, because if you would. So there's always this push-pull to it. So I guess I was trying to go slowly to do this, and I think in the States at least, one of the issues we have, possible ways out there.
So I will. Can you follow your speech?
Just to say, if I put in the plumbing pipe before I put in the duct over it, doesn't matter if it's coordinated, I cannot get the duct in once the plumbing pipe is there. So what you're looking at almost looks like a sequencing based. Using consumption of coordination, have some coordinated model, have some expert something that gets down to what you're doing, basically demonstrating this is the order you must put it in which way something will fit. And that would seem like maybe an appropriate approach to look at, because sequencing is so critical there, and one issue has huge ramifications, so it's very easy to prove which one that is.
Well, we are like originally we were more in shipping industry and other industries, so actually construction was kind of new to us.
Yeah.
And we were just trying to get into it just for years.
Yeah.
So scaffold was one of these we had, and then this, I remember this war with the name was, but like we don't really have any further ideas of what others could be.
Yeah.
So I was trying to wondering to.
I think that would be good. I tend to anything that leads to anything we're not good at doing right now is a good start.
Yeah.
So I think at least something like 3D coordination, installation of coordinated content could be one that I don't frequently see issues with that people don't do it right. That would potentially be an issue. You could even see something like not use it as a training tool for setting, but use it as a quality assurance check. So that I go out and I know the order, and I can do it or something like that, and look up and see at this date and time, these systems should be installed. And these should be red. And I can visually check green, yes, it's installed green, yes, it's installed red all the time. You know, and you could almost see doing something like that training for someone that because there again, if it didn't work and it's not what was intended, at least you know immediately. And you may have time to change the situation. That could also be another direction that maybe we consider.
Thanks a lot.
Yeah, I don't know if that's helpful.
Yeah,
It's kind of new to me, but I think the concept is really, really creative, and I really like it. I was just, my aim was not to be negative and asking about construction. It was more of just, by its nature, you're starting with a basic task. So it's sort of like, okay, so how do we go from the basic to something in the construction realm where, you know,
Yeah, the first one. This one, yeah.
difficult to train, and it would also be enough specificity that someone using it really gains utility out of it.
I didn't take it.
Okay,
That's
good,
kind of
good.
a point of comfort,
Yeah,
isn't it?
well, I think so.
Do you have video inside
thanks a
your?
lot.
Yeah,
Absolutely.
I wanted to check.
Bye.
Let's
Yeah.
see. Can I just quickly play it? Is this a video? No. Okay.
Yes.
Okay. Great. Great. Yeah. I'm move.
Yeah, shall we take a step outside?
I just want to run, you know.
Okay.
Only if you give me good suggestions of restaurants to go to or other places I should
Okay.
go.
Cool. Sorry.
Got all my notes down.
Sorry? Are you leaving? No, I'll leave. Oh, are you the chair? Yeah, I'm the last presenter. No. My name is Ryan. I'm the boy Ryan. Ryan. Yeah, Ryan. Yeah. Is it a Korean name? Yeah, I'm actually, but the one that says TMU. Yeah, don't worry. So, you are from?
Just from this university.
Okay, are you in the
Civil engineering department. But my research is about using BIM for construction management.
Oh, Capta. So when did you start? I mean,
Just early this year.
early this year. Oh, so it's the first year.
Yeah,
Where did you get the PhD?
in the UK.
UK? Which university?
Liverpool University.
Oh, Capta.
Have you just worked for KMU for many years?
No, it's my second year, and then before there I was in the University of Nebraska.
Okay. Is this your first time to New Zealand?
Yeah. I explored.
I went to Chicago in October for the CLB-W7.
Oh, yeah, you were there. I didn't attend, but I've heard that. So it was
really likes Chicago.
Really?
Beautiful
Because you went there
landscape.
during the summer. If you went there during the winter, you will not like it.
So you just come to New Zealand at the right time, summer season.
Are you guys gonna present?
Yep.
Cool. So which
the-
one?
The last one.
Will be the last one.
Yeah.
Cool. It's 2 files.
This is my file.
Oh yeah, that's yours. Cool. Oh hi. Which one is
So,
you?
the
The first one. Oh,
yeah.
cool. So the last one?
Yeah.
Sweet.
Thank you. So there is no controller or something, right? We don't have a flicker, so you have to use the keyboard to flick through the slides.
Okay.
Yeah.
That's fine.
Yeah, sorry about that. We used to have some, but like it's just gone missing.
Hey, Ryan, you have
What's that? Are you the chair?
Yeah.
Oh, cool. My name is Xishao.
Shisha?
Yeah,
Ah,
nice to meet you.
nice to meet you.
Nice to meet you.
Yeah. Are you student in architecture?
I'm graduating. Yeah, this is my 5th year.
Fifth year?
Yeah,
Oh,
so almost there. Yeah.
So you're doing architecture?
Architecture.
Okay.
Yeah.
Have you found a job here?
I'm currently looking.
Looking?
Yeah.
Is it good to, is it easy to find a job?
The job market is not very big because like we have a really small population. But yeah, I'll just keep trying. Yeah. So do you need a reminder for time?
If you can.
All right, cool.
Yeah.
Cool. Because normally like people are not taking too much time for the presentation.
Yeah, because when you have 3 speakers, then my feeling is if they do not say too much, I think
Right.
it should be fine. Yeah. But if you can, maybe.
Oh yeah. I will.
It's good to just
Yeah, I will keep an eye on it. If we reach like to the limit, I will just.
Thanks very much.
So are you in the construction industry?
Did you do a final year design project?
Oh, I already did it. So I'm currently just writing the book.
I have a structural background. But every time when I saw architectural final year design, it's amazing. All images are after rendering.
Yeah, the structure is not possible.
Yeah, for structural, it's not that attractive because you just see the columns, names of bridges.
Yeah.
But it's not like architecture.
Right, yeah. I can show you a quick clip of our final project.
Yeah, of course.
It's just, it's about VR and architecture. So we're trying to plan that together.
Are you doing the project? Did you do the project in Benelux?
No, the last one is the first one. There's another school. Yeah, so he's more interested in like large scale installation. So we have like basically we construct everything physically, but there's also a digital equivalent.
Are you sure? You're not too close to the
speaker to come.
take some photos. So they invite you on the side of the road so we can have a chat. So
Yeah,
have a
yeah,
research.
I think I have a coffee before with Matt.
Oh, okay. Money is cost provided.
Yeah. Close to
So yeah,
and
it would be yeah. If you feel interesting.
yeah, of course. Lima, do you have a USB stick? We already done.
This one, yes, yes. Okay. Okay. Should be work.
That's what I want you to in your presentation. Have a section say preliminary studies that we conduct. And then put the results of this there. So how we compare to. That is important. You can say we've got this result, so we already published it, so it's out there. So we're not anxious.
Hi, hello everyone. Welcome to the last session here. My name is Yang Zhou. I'm a lecturer in the University of Auckland. I'm chairing this session. Our first speaker will be Hassan Aliwa, who is a PhD student at the Auckland University of Technology, and his topic will be information technology and the New Zealand construction industry, an empirical study towards strategic alignment of projects and organizations. So I just leave it to you.
Good afternoon, everyone. It's great to see you all here. Thank you for coming. I'm Hassan Aliwa, PhD student in AUT. And I'm doing this both with Dr. Mustafa and Dr. Mani from AUT. And my research about information technology and New Zealand construction industry, an empirical study towards strategic alignment of project and organization. First, I want just to highlight some points as introduction and for problem statement. We all know that the construction sector is the key driver for economy for worldwide and for New Zealand especially, and all construction, as many industries rely on information technology to improve the productivity and performance of the projects. Information technology, we can define the information technology as like a technology or equipment that can be used to store, and transmit data in construction industry, such as BIM technology, CAD, and so on, project management technology. However, there is like a significant challenge to improve the productivity using this information technology. And if we check this chart, we can find that the percentage of projects finished on time in New Zealand in the last 10 years, and the percentage of information technology used, we can find out that this year, almost all projects in New Zealand are using information technology. However, the productivity is still the same. So the main problem is that the construction industry is underperforming comparing with the other industries using the information technology. I got this chart, which is comparing the labor productivity. We indexed 1978 as 1000, which is, we can say, like information technology revolution. Yeah, and we can find out that construction industry, which is in orange color, the productivity is declined or still the same comparing with the other industries, which is using the information technology as well. A report from Ministry of Business identified that New Zealand business are failed to utilize the full potential of information technology to improve the business outcomes. Another report from Siebel Group, which is the largest expert group in New Zealand and Australia, found that New Zealand organizations that make more comprehensive use of information technology, just 6% more productive than the other construction project which not using the information technology. So the percentage is very low. In the same report, they highlighted that the construction and transportation sector area has the greatest chance to improve their productivity if they can use the information technology as a strategy in their business. A report, which is the annual report from Christchurch Study Council, found that although 90% of the projects in Christchurch using the information technology in any way, just 60% of the projects finish on time, which is half of the project finish on time. Other the same for Auckland Airport development and operation sectors. They have two projects there, which is Airport Phase 4 and Phase 3 projects with total 1 year behind, and they spent $2 million to implement some sort of information technology, which is Acronos and co-construction, and their project still behind. The same for Auckland Transport as well. They was using Keystones and Synchro, but still their project behind. Recent studies highlighted the value of strategic alignment or management and its positive impact on organization performance. A lot of literature demonstrated that organizations are encouraged to align the information technology with their business strategy to benefit from the use of information technology in terms of increasing productivity and the performance and or company outcomes. Just want to define some elements here, like strategy can be defined as a various activity that strengthens the competitive potential of the organization. Information technology strategy utilize the strategic potential for information technology in business. And the strategic alignment is a theory about that. If we can align the information technology with the business strategy, we can have like a projects doing more professional outcomes, and we can increase the performance of this project. In general, I just want to summarize everything that it's required to analyze the connection between the information technology and the business strategy to be able to implement the business strategy in proper way and to increase the performance of the project or organization. From our researchers, found that in United States and in China, by implementing the strategic alignment, the projects have been performed well by 50% in the United States and by 70% in China. And here are the main objectives of the research. So it's to analyze the existing connection between the information technology and implementation and the business strategy itself. I have scoped that the case study is in New Zealand, and I'm just considering the construction organization. As I said, this report or this research is a part of my PhD, and in my PhD we are studying this area in the wider range, and we have a lot of activities or objectives that can be used, and we can like find out more about the strategic alignment and align the information technology with the business outcomes. So first, I want just to discuss the strategic alignment model, which is a model which will be used for a strategic alignment between the information technology and the business strategy. This model have been found by Henderson in 1989. We have four models, four domains, 2 internal or strategic domains, and 2 external or infrastructure domains. These domains are business strategy, which is related to action or to achieve the specific objectives of in the business, like business culture to new information technology, business strategy for information technology implementation. Second domain, which is information technology strategy, which is related if the business or organization has a written information technology strategy, or they are spending on the information technology, or they have like a budget for information technology. The other domain, which is organization infrastructure, which is related to the infrastructure and the management structure of the organization itself. A lot of things which is information technology infrastructure, which is related to the hardware and software for the information technology, which could be used in construction organization, for example. The alignment, we have 2 alignment level, which is strategic fit, which is between the external and internal domain, which is, for example, to align the business strategy with organization infrastructure, or information technology strategy with information technology infrastructure. The other alignment, which is the more important one, which is functional integration, which is related to the alignment between the infrastructure and the information technology and the business. For example, business strategy with the information technology strategy, or organization infrastructure with the information technology infrastructure. The main idea is to calculate or check the weakest and the strongest domain. And by calculating the weakest domain, we can find the weak area which needs to be improved. For example, if the weakest domain is the organization infrastructure, so the driver will be a business strategy, and it will affect on the information technology infrastructure. And the problem will be with the strategic execution. If the weakest domain is information technology strategy, so the driver will be business strategy, and it will affect on the information technology infrastructure. And the problem will be with the technology transformation. The same for the business strategy as well. If it's the weakest domain, so the information technology will be the driver in this case. And it will be with the competitive potential. And the service level problem will be if the information technology infrastructure is the weakest area, so the driver will be information technology strategy. My main research question is, do New Zealand construction firm have a clear information technology strategy aligned with their business strategy? And if the construction organization in New Zealand can manage the strategic alignment between the information technology organization infrastructure and business strategy? I have another questions for my PhD, which is, well, why the research and check more options in this area. Sales methodology, which have been used here. It's a case study research methodology. So I selected expert semi-structure open-ended interview with the project managers or people within the management level. So just to highlight the expert semi-structure interview, provide foundation for validation for other researchers, and also it's important that than the survey, which is the people can add their comments and we can expand the questions and study. Using Nivivo software, I analyze the data from semi-structure interview into yes or no, or agree or disagree, to be able to draw the chart and to calculate the weakest domain, as we're gonna see in the last slide. So it's mainly two stages methodology: theoretical review, which is related to literature review for organization to check the problem for with the implementation of information technology. The stage 2, which is the practical investigation, which is the semi-structure open-ended interview. And my scope was, we was looking for the construction organization in New Zealand, Auckland, and the interview with the people in the management level with a good experience in construction and experience in using the information technology. Project is completed or 70 or more % completion. So the project is not new. We have experience in this project. We have a history. And projects is like started within 5 years. So it's not like all finished project. As I said, it's semi-structure and open-ended interview from people from 5 different construction projects. Auckland Airport Phase 4 and Phase 3 projects, Buckhead Hotel, which is in the waterfront, Causeway projects from north coming to the city, and Lincoln Road infrastructure project. 13 experts have been, or we was able to get appointment with 13 experts from those projects. A lot of experts selected, but this was like we got appointment and we was able to interview them. Most of them with a big experience. We can find that there is 10 years experience for some of them, and the maximum 33 years experience, and a lot of them was using byproducts in their projects like VA and AI and wearable technology and so on. And here here the results we got. For a business strategy, it was on strong level, and this is usual, because if there is a problem in business strategy, so the problem with the organization itself. So we expected that the business strategy is already on strong level, and the information technology strategy as well was on strong level as well. However, which was already expected, which is the organization infrastructure was on weak level. And this affected the information technology infrastructure itself, which is make it on the weak or mid-level. So the organization infrastructure affecting the information technology infrastructure, and we can find out that the main concerned area or problem, considering the case studies, is the organization infrastructure. As I said, this is a part of my PhD study, and in my PhD study, I studied the underperforming of the information technology in New Zealand construction industry in total, and I'm gonna just use this case study as like a guideline for my PhD. But for PhD, I'm gonna like study the information technology in a wider range, and I'm gonna check if there is a problem from the information technology itself or from the alignment. Thank you so much for listening.
Any questions? Okay, Hassan, so have you just, my question is, have you just considered how to learn the experience from other countries like Korea, Singapore, and UK?
Yeah,
Because I think
yeah, we can use the same same structure of the methodology for other countries, and I think the same result we will get, which is the organization infrastructure will be the weakest area, because the most important part, which is the function integration part, which is between the organization infrastructure and information technology infrastructure. So if we can align these two domains together, I think we can implement the information technology in a proper way, and we can improve the organizational performance. But this area needs to be studied in wider range. Yeah.
Okay, thanks. Cool.
Thank you.
Any other questions? Joe?
You're tackling a lot of very interesting challenges. How do you go about measuring? What are some of the measures that are in that infrastructure technology, or the IT infrastructure? What is in that?
Yeah, so the measuring was based on the questions. So from this interview, we like summarized some questions, and using the Nevivo software, I analyzed the questions based on yes or no, or agree or disagree. So the information infrastructure itself related to the byproduct and related to the softwares and hardwares. If the company has like a proper softwares or hardwares, that can help the organization itself to improve the outcomes of the organization and the performance of the organization, so the information infrastructure will be in strong level. But still the organization infrastructure will affect on the information technology infrastructure. Because there is a direct or indirect effect. If the structure of the company is not in the proper way, so the information technology implementation will be affected.
Do you find it hard to separate the organization from the project? because you're talking about project organizations and then company organizations.
Yeah. For my PhD, I'm studying just the organization. But here, because I got some case study from project on different organization, so it's because it's a construction project, so there is a link between the project and organization itself. But it's mainly for organization.
By the way, the other question for you is, how can you differentiate the views from probably different people, and especially some people from large firms and some people working for small firms. So especially, for example, in New Zealand, we have very large construction firms like Hawkins and Fletcher and some other small, like family-based business.
So as I said, this is like a small study for my big PhD study. In PhD study, I'm gonna develop like decision support system, which can help all firms from different levels of like large firms, mid firms, or small firms to use the same strategy and to check their weakest area or weakest domain. So,
is it correct they're using the same strategy for the size
for the big project and the small project? We're gonna find out this in PhD, so we can't.
What's investigation?
Yeah.
Okay.
Investigation.
Okay. Thank you very much.
Thank you.
Our second speaker, Dr. Zhang Li Mao, who is an assistant professor from Nanyang Technological University, Singapore, and his topic will be monitoring design productivity through process mining of BIM log data.
Yes. Okay. Yeah. Thank you. Thank you, everyone. My name is Li Mao Zhang, assistant professor from Nanyang Technological University in Singapore. So, the topic of this presentation will be about the BIM logging mining. I think this may be the first time you heard about the BIM logging mining concept. So I hope I can give you, satisfy you, and give you more understanding about this concept. And the work is mainly done when I was a postdoc at Georgia Tech with my advisor, Dr. Babak Shuri. And I moved to NTU last December. So, and in this presentation, I will share with you some preliminary results in this conference paper, as well as some continuous results beyond this conference paper. So the main objective is to monitor and measure the design productivity through the process mining of the BIM logo data. Okay, so here's an example. So I think everyone has experience for buying something from Amazon. So when you finish your payment, the Amazon will give you some recommendation, right? And most times you can see this recommendation is correct. Have you ever considered what's the secret, why Amazon is so smart? Actually, the main secret lies in the local data. So the Amazon actually will record all these kind of the behaviors from users during the online payment, online shopping and payment. So for example, they can record at which time point you are in this website and how long you will stay in the website and what is the subsequent website you will move to. So all this kind of information will be stored in the format of the local data. And in the BIM design process, there are also this kind of the local data. So they will record the design behaviors at the time when you do your design models. And our research idea is to incorporate some process mining technical with the BIM log data to help provide some design support and help provide some information in the design process. So with the growing applications of BIM in the industry, a lot of the local data will be generated. So far, we have built up a database for the storage of the local data, and the volume is more than 20 gigabytes. It's a huge data resources. And the figure here can show you a general framework for the BIM-based process mining. So first, we will design some BIM models, and then we will use this kind of local data generated in the design process. So generally, we will focus in this research, we focus on the Revit. So now the local data will be stored in the dictionary folder of the general file, and then we use some process mining to provide some information to improve the process behavior. And the potential application will mainly focus on the productivity measurement, automation, automated construction design, and also some like the training and the education. So here give you an example. So the video here can show you the workflow of the design commands and their interactions over time. So here the load can show you the specific design task, and the moving flow can show you the flow of the design, the speed. So you can see some workflow is very fast, some workflow is very slow. So some slow part can act as some bottleneck for the whole design process. So, and this kind of the visualization of design flow can help to identify some design bottleneck and also improve the design process. So for example, we can identify some most frequent design paths for some old designers who have a lot of design experience for the education of younger designers to help them to improve their design in a very short time. So actually, there is really a long debate on how to measure the productivity in design since the end of last century. So as you can see in the construction process, there are several metrics that have been proposed. So for example, when you make a wall or build a wall, so we can see, okay, how many square meters you will finish per day or per hour for one worker. So it's reasonable. But in the design process, if you say, okay, how many journeys you produce per day or per week for one designer, maybe it's unreasonable. Why? Because project is different. Some project is very complex, some project is very simple. So in this kind of sense, and also compared to the construction productivity, the productivity in design will be more complex because the design is a more innovative process. Particularly, there are many kinds of the collaborations in the design process across different disciplines, like the architecture, structure, mechanical equipment, this kind of things. So in order to address this issue, we need to find out, so what kind of data can be used to monitor, and what kind of the metric can be used to measure the productivity in the design, particularly in a more efficient and objective manner. So this is our research concern. So here about our research roadmap. So we are greatly motivated by the fact that a lot of design process information will be extracted from some local data. And based on the data, we can perform and conduct some research activities like the process mining, the social network analysis, and then we can discover some new knowledge regarding the relationship between the design process and productivity as well as the social behavior, and to provide some design support for the design process to help some like the collaboration to improve the productivity. So the first step is the data collection. So what kind of data we can use? So actually, the figure here can show you an example of the data collection process. So generally, all this kind of the local data will be stored in a time format. So we will use some text mining technique to extract some information related to the design process. Like in this example, we can extract the user ID, the project ID, and also the timestamp and the contents of the design command. So in this procedure, they mainly have about some main sub-steps, including the time harvesting, data parsing, and also data cleaning, because they have a lot of noisy. The figure here can show you the flow chart of the data organization. As you can see, in a design firm, so there should be a lot of the projects they are running in parallel, and each project there are several designers will be involved to working together, and each designer will generate a folder for the storage of the local data, so during the design process. And then this kind of the folder will be uploaded to the system server, so then we can use a general file parser to translate some the raw text files into the structured CSV data file. So the table here can show you an example. So this kind of the structured CSV sample data. So there are many columns. So those columns can represent the information required for related to this kind of a design process, including the user ID, the project ID, and also timestamp, as well as the concepts of some design commands. So in the last page, I have shown you a time series of the design commands. So maybe you can say, okay, we can propose such kind of a metric. So how many design commands are executed per day or per hour for a specific designer? But actually, in this kind of things, they also didn't consider about the project difference. So some will be really easy, some will be very complex, so it will also not so good. So in this case, in order to suggest this, address this problem, we will identify the patterns of design process first. So these patterns can represent a sequence of the design command within a log session. So it means that sequence of the design commands will be executed repeatedly. And the main objective is to provide a unit basis to measure the productivity and also to eliminate the project difference. Because here the patterns can represent a similar scope of the design process. So this is our assumption. So based on the discovery, the design patterns, we can do a note of the design analysis. So here is one example. We use it to measure the productivity in design. So the figure here shows you about the top 5 the design sequence patterns that are mined from the design log data. So as you can see, for each pattern, there are maybe 3 and 4 design commands. They are executed in sequence. And here the figure shows you the process duration of the different patterns for specific designers. So some designers will execute the pattern 1, 2, and 4, and 5, and the y-axis represents the time, the process duration. So the figure here can show you the final result of the productivity measurement. So as you can see, the blue line shows you the productivity performance of the whole organization, and the blue point here in the middle is the mean value. It shows you the average time required to execute this pattern. And the red point can show you the productive performance of specific designers. So you can see if the red point is on the left side, so on the left side of the blue point, it means he requires less time than the average. So it means his productivity will be higher than the baseline. If the blue point is on the right side of the blue point, it means his productivity is lower than the baseline. So this kind of the measurement of the productivity in the process. And also, the discovery of patterns can be used as a tool to detect some outlier performers, which require additional attention from the project leaders. So the figure here can show you the box plots that are summarizing the production rates of different designers in executing the pattern 1. So we choose pattern 1 as an example. And here the designers are represented by A to U, and here the y-axis also represents the process duration. As you can see here, the yellow area represents some mild outliers. It's outliers, but also serious. But the pink area shows you the extreme outliers. Those kind of the designers should be paid more and specific attention for the future improvement. So as you can see, the control chart here provides a visual tool for the project leader to evaluate and assess the performance of the different designers in the team for benchmark. So for the study, the main important is about the validation. So how can we validate the effectiveness of our proposed approach? So here we try to explore whether the learning effect will exist in the BIM design process. Because according to the learning theory, we see when our humans do something, the similar things repeatedly, we will be faster and faster. So, and here we also, the figure here can show you the scatter plot and the regression fit of the process. We take the pattern 1 example among 6 designers. So the x-axis represents the time scale, and the y-axis also represents the process duration. And as you can see, the red line here shows you the regression fit. So all the regression fit goes down, and because the slope or the negative. So it means the time required to execute the same pattern will be reduced when they execute more and more patterns. So this kind of result will be finally consistent with the learning theory. So to a large extent, the effectiveness of this approach will be testified. So the other application is to discover the social networks. So here, as you can see in the figure in the left, you can see how we build this kind of collaboration. So we assume that if different designers work together in the same project, we will see there should be a kind of collaboration. So when we account all this kind of collaboration throughout many projects among different designers, we can build up this kind of social network. So it's very data-driven. So, and this data is very easy for our access. So, and here for the social network, the node represents different designers, and the link represents there should be a kind of collaboration between different designers, and the vice of link can represent the strengths of the collaboration. If the Y is very wide, means they have a lot of strong collaboration. So based on this kind of discovery social network, we can do some measurement in terms of the social behavior. So here the figure can show you the measurement of the node degree centrality, so by the link and also by the weight. So we can identify who is the leader person, so in a central position, and who is the marginal person, so in the outside. So it can provide a visual tool for the project leader to see, okay, who should be potentially is a good position for this one to be the leader. So this kind of things. And we also perform some correlation analysis and find some interesting results. So one biggest significant result we find is that we demonstrate there should be have a strong and positive correlation between this kind of social logic characteristic and the typical performance. As you can see in this figure, the x-axis represents the social behaviors, so in terms of the node centrality degree, and the y-axis represents the production performance. So in terms of the regression fit, we can find out that the measured node degree centrality can explain more than 50% of the production performance. So this kind of result we demonstrated using our data captured from the local data. So as you can see, as a result, we can find out in the actual practice, we can pull some designers, maybe from the outside, to pull them towards some central position to enable them an environment to help them to build a relationship and make them more social with other designers will have a bigger potential to improve the production performance in the design. So this kind of result is we can find out from this kind of empirical study. So for the future study, actually there is a long way to go. So actually our group is the first group to study about the BIM local data. So I hope that we can continue. So one specific area is we will try to explore the evolutionary mechanism of the learning process from peers. So for example, we can testify whether you can learn faster in a large group or in a small group, or whether you will learn first in some collaboration with the old, the senior people, or with the younger people. So this kind of testing. And we will also try to simulate the design behaviors and try to do some prediction and optimization for our future study. Okay? Yeah, thank you so much. So, yeah, thank you.
Thank you, Li Bao. Very interesting work. Right, you have a question?
Oh, it's very interesting work. I mean, I really like your approach. I'm not quite clear about your approach address the challenge in the measuring the design productivity you mentioned. You know, the design process is quite, creative, and just creating the same command may not mean that they are doing the same amount of work. You know what I mean? creating the door in one place, zone A, will not be the same with the creating the door in zone B, because zone B, the design is more complicated.
Yes,
So it may not be, I mean, measuring the productivity in that sense still not going to be fair, right?
Yes, yes.
So I mean, but feels like your approach is still not considering that part, right?
Yeah, so I think for this kind of is the main contribution we want to propose, because different project different. Some is complex, some is easy. So we just propose the patterns to represent a similar scope of the design task. So this kind of similarity can represent, okay, different person, different project, they are doing some similar issue. So we just do some measurement for this particular behaviors, and we can give some information as a dashboard to check, okay, who is good and who is not so good. Just, I think this kind of tool is not just to evaluate their performance who is high, but just give them some insight to see, okay, who is the outliers. If you are outliers, okay, what's the reason why you are outliers? To give the project leader some additional information for the project management. Okay, thank you.
Yeah, I have kind of similar concern. So I don't know if you have tried to tie the productivity at the micro level as you're measuring, like producing or certain specific task or pattern of tasks with a macro approach. So maybe the drawing, as you were saying, is not the best unity of measure, but another measure that shows you if all those small tasks that you are measuring in the log file relates to the final output. Because maybe you're doing a lot of small things and very quickly, but anyway the final output is not optimal because you're doing something in between that is not reaching the goal. And in the same line, I don't know if you are considering that in those patterns the rework. Like, for example, maybe you do a lot of doors, but then you delete a lot of doors too.
Yes, yes, yes.
So I don't know if that is considering those
Yeah,
patterns.
for this kind of research, we didn't consider the rework. So rework is, to some extent, is about the quality. So we will propose for our future study, we will consider about the relation between the quality and productivity. So whether it means the high quality is high productivity or high quality is a low productivity. So this kind of relationship is actually, we do not have some specific object data for the demonstration. So we will maybe use this as a background to do some demonstration. Yeah, when we work. Okay, thank you.
I just wanted to tag on to some questions. So it seems like you have to define productivity in a more clear manner.
Yeah.
Is achieving a milestone with more commands a good thing, or you want the designer to achieve a milestone with minimum number of commands possible? And then same thing that was mentioned, rework and undoing the work that has been done during the day. So that relationship was not really properly because you're basically looking at the log data, which is a long list of commands, timestamp commands, but it's not necessarily it may not be necessarily the best way of achieving the final objective for the design.
Yes, yes. I think you are correct. So here, so we do not just say if you execute maybe a million design commands, you are good, and you only produce some 1,000 or 10,000, you are not so good. We just identify the patterns of the behaviors. We use this kind of patterns to represent, okay, so provide the basis for the measurement. Yeah, so this kind of basis for the activity.
I think Gun.
Yeah, I've done a similar thing a while ago, and I was not successful, so I found it very interesting. So let me share my experience why I failed. So one of the reasons was the patterns that we found was like copy paste, copy paste, copy paste, copy paste, and I'm not sure what your patterns include, but it was very difficult to find meaningful patterns. Like activity, probably you need to have their daily schedule too, so that you can kind of get rid of the medium time during the set.
Yeah, this is really a good command. Actually, we also mean it's challenging. When we identify these patterns, we want to explain what the meaning of these patterns is really difficult. So this is also the limitation-based approach, but we will propose in the future, we will try to do some modification. Because here we just see, okay, we use the Franquist pattern discovery algorithm. So it means all the sequence of the pattern is the same. So copy paste, copy paste. But actually, if we want to find the meaning of the specific patterns, we may need more design commands. So we will use some fuzzy issues to see maybe they are not exactly the same for different patterns, but they have some similar meaning, so we can then explain. So it will be for our future plan.
Another thing that you need to look at is you need to know what they are actually doing.
Yes.
Why are they copy and paste? If they work on very complex shape ones, probably they will use different commands. So you need to actually know what they are actually doing.
Yeah. Thank you.
I'm sorry, Claudia, we have to move on to the next session. Maybe one comment on Lee-Mouse, your work is that you have to just validate the results. For example, you can just take some very simple questionnaire to the designers to compare if the results match the real situation.
Yes, yes.
Yeah. Thanks,
Thank you so much.
Our third speaker, Ryan An, who is associate professor of TAMU University in Texas. And his topic will be frequency domain analysis for Wi-Fi-based human activity recognition systems in smart homes.
Hello everyone, my name is Ryan and I'm in the Texas A&M University. Today I would like to talk about the effects of the housing environment on the performance of the activity recognition system using Wi-Fi signals. Subtitle is Exploratory Study. I mean, it's a little bit different with what I presented in the paper, but somehow related to the paper content. So also includes some of the continuous research. Before talking about the contents, I would like to acknowledge the contribution of my co-authors. Hoon-Young Lee, first author, he's my PhD student who did most of this work, and then the Dr. Nak-Chung Che, he's a senior researcher in the Nokia Bell Lab. He did most of the data collection system and then providing some consultancy regarding the Wi-Fi communications. So here's the contents. So recognizing the activities of the daily living, we call the ADLs, in the smart homes and smart buildings provide a lot of the benefits. First one is providing some building automations by recognizing the occupants' behaviors. We could automatically control some of the HVAC systems and lightings and so on. So it will provide energy savings and also some of better occupants' comfort. And then another benefit will be related to the remote healthcare. So, for example, especially for the elderly people, when they have some emergency accident, like falls, then it could automatically detect their falls and then connect to the healthcare providers. And actually, that the monitoring the ADLs of the elderly people, not only for that the falls or those emergency accidents, just the regular activities, providing some critical information about their health status related to some decline of their physical ability and the mental ability. For example, that when they have some dementia or Alzheimer, the patterns of the ADL starting to change. So there is a reason why there are so many approaches trying to capture, monitor ADLs of some elderly people, especially in their homes. There has been many approaches. First approach could be using the camera, but it has some privacy issue. Especially going to the bathroom is one of the key information in judging their health status. But we cannot put the camera in the bathroom. Okay, we cannot differentiate whether they are taking a shower or whether they are actually using some toilets or not. And also the camera has a line of sight issue. Another approach could be using the wearable devices, but many studies found that asking the elderly people to wear their wearable devices for 24 hours doesn't work. I mean, it didn't work. And then especially elderly people with some Alzheimer or dementia, they keep forgetting to wear those. So there has been some attempt to use those Wi-Fi signals to recognize the activities. Okay. Let me briefly talk about how it works. Okay. Oh, so when the Wi-Fi signal using Wi-Fi signals, I mean, it could be based on the existing Wi-Fi infrastructure, like using the off-the-shelf Wi-Fi devices, and it doesn't have any line of sight issues. Elderly people does not need to wear any devices. So I would like to explain how it works. I mean, I'm not a Wi-Fi communication expert, so I just want to explain based on my understanding. Under current Wi-Fi protocols, the data, when the data delivered through the Wi-Fi, usually it travels through the multiple paths. The one data packet travels through the multiple paths, and then the received signals consist of those signals traveling along the multiple paths. Then the signals through each path somehow will experience some of the environmental effects. So it will be reflected, or somehow its power decay, and so on. So the walls and furniture, even the human bodies, will affect their signal strengths and the other properties. And then the channel status information, what we call the CSI, provide information about the environmental effects on the signals that travel along each path. We call the subcarrier. So when there is no movement, no dynamic objects within the certain environment, then those CSI remain quite static. But if there is some dynamic objects, some moving objects there, then the CSI becomes quite variant. So let me show you some video we took from the experiment. So here, this is the subjects, and then we show that this is a transmitter of the Wi-Fi. We have the two receivers, one in the kitchen, one in the bedrooms. And then this one shows the data we collected from the kitchen receiver. This one shows that the data collected in the bedroom. And then x-axis is indicating the subcarrier ID, each path. And then y-axis indicating the signal power we collected from each subcarrier. Okay, so you will see that this subject moving from the living room to the dining room, it will affect the signal power of each subcarrier in some way, and then that effect to each carrier is different. So if we look at the data in the time domain, it will be looking like this. So when the subject was in the bedroom and no activity, then you will see that the signal patterns are quite stable. And then as he's starting to walking from the bedroom to living room, we will see the great level of the fluctuations. And then as he now stands in the living room without much activity, then the signal becomes stable again. But another key point is that based on the location of the subject, the signal patterns are different when he was in the bedroom, when he was in the living room. So using these properties, using these conditions of a CSI information, the channel status information, recognizing the human's activity is possible. There are a lot of the study has been done already, and then some studies are trying attempts to recognize recognize activity as a very high resolutions. For example, there one study trying to detect the breathing rates of the subjects by installing the transmitters and receiver in the bed of the the subjects. And some research, some study trying to detecting the keystroke actions. So they could just tell that which key the subject is striking using that signal. But that is like a transmitter, and then the receiver is here, something like that, very closely. So many studies has been done, and especially recognizing the ADS in home has been done a lot. But most of those studies are done in the very controlled laboratory settings, because this Wi-Fi CSI is very sensitive to the environmental effect. And some are trying to do in the real home environment, but most of them was done in the US home environment. However, we know that the housing environment are different by the country, and then again, Wi-Fi signals are quite sensitive to the all surrounding environment, even for the building materials and layout of the house, and so on. So we had some questions about how does those housing environment will affect the performance of the ADL recognitions. Here we had some targets. Like one is that the typical U.S. homes
goes into sleep every 3 hours.
So let me continue. One is a very just typical, the single family, the U.S. homes. In U.S. homes are, structural materials are made by the wood. Even the interior walls are made by the wood frame and the drywalls. And another home we'd like to investigate was the homes in the Korea, which is usually in the high-rise condominium, and their structural materials are usually concrete. Even the interior walls are the masonry walls. And then we know that concrete inhibits the propagation of the Wi-Fi more than the wood. But there is something is not clear. It could work in the good way, could work in the bad way. In good way, it may block the interference of the surrounding Wi-Fi networks. But in bad way, it may also block the Wi-Fi propagation within that units. So we'd like to test it, and we'd like to know somehow how it will affect, right? So we picked the two units, one in the US, one in the Korea, and then do some actually collecting the data. The US one is a 3-story multi-family housing, and then again wood framed the units. And then the Korea is high-rise concrete framed condominium units. We picked those two units has a similar size, and then 6 subjects in each site. We collect around 400 samples of the activity in each site. And then when we use the same data collection devices, and the distance between the receivers and then the transmitters are same. And then most of the activities were occurred in the kitchen and living room. And we tried to classify the activity into 4. One is walking, eating, typing, and no activity. So here are kind of the general process of the activity recognition using the Wi-Fi signals. Once we collect the data, we need to pre-process it. We need to remove the high frequency noise using some filter. Then we need to segment the data. So that will tell us when the activity change. Okay, we use some moving variance based algorithm. Then we can classify using some of the learning algorithms. In classifying those activities, we use 2 methods proposed by the previous literatures. One is called the Y-chase. This is a quite straightforward machine learning algorithm that using support vector machines. They are computing the 6 features from each segment and then using it to classify which activities are occurring. Another approach, so then they will use it's a typical 70%, 30%, like 70% training, 30% testing. That data, the rule is applied for these algorithms. Another algorithm is EI. This is the very first, this algorithm was proposed by the very first paper that using the CSI, the Wi-Fi for the activity recognition. But their approach is a little bit different. They creating the profile of each activity using several representative data samples. So this is a kind of the example of the profiles. So within the segments, they are counting based on the amplitude of each subcarriers, they are creating these types of histograms. Then, when for some segments that needs to be estimated, then they are measuring the similarity between this distribution and distribution of the test segments. Then based on that, the similarity, they are predicting the activities. As you see here, that this is a profile from the walking from living room to bedroom. This is a profile for the walking living room to kitchen. Although it's the same walking actions, but the path is different, so their profile is different. So, yeah. Then here's the result. Of course, I mean the Y-Chase is using more data as training, so they usually have a higher performance. And then EIs, because their training load is quite low, so performance is low. So it's not going to be, just comparing those two algorithms, it's not going to be a fair comparison. So in general, when we use a Y-Chase, we have a better accuracy. But when we compare US versus Korean homes, we see that in US, some higher accuracies. When we use Y-Chase, we have a 7% higher. When we use EIs, 9% higher. Okay. So but the confusion between the activities occurs differently based on the algorithms. When we use the Y-Chase, the confusion between the walking and in-place activities like eating and typing occurred more. However, when we use EIs, the confusion between the no activity and some in-place activity like eating and typing occurs more. So somehow now we confirm that the difference of the housing environment certainly affected performance of the ADA recognitions. And then we are thinking that it is mostly because of the construction materials. However, we cannot say that because there may be many other factors. We were not able to 100% control all other factors. So, of course, number one reason, as we think, could be building materials. But another factor could be the Korean homes. It's a high-rise condominium, so they are in the number of units per same area is more, which means that there is a great chance that we will have some interference by the neighboring Wi-Fi networks. Although concrete material could block it better compared to wood, however, still it has some openings like windows, right? And also, although we picked the two units that has a similar size, but layout is different. But still, most of the activities we'd like to classify was occurring in the living rooms, but still housing layout may affect. So still we need to investigate more exactly which factor affecting how much. But that's going to be our future research. Then so what? So once we know that housing environment affecting this ADA recognition in some way, then how we can address that? I mean, there will be several ways, but one of the ways we are thinking is that maybe tells us that how many receivers we need to use or where they need to be located. So in our experiment in US, we actually use 3 receivers, although we reported the results from the 1 receivers. The receiver we reported was located in the dining room where the most of the activity occurs. However, we employed another 2 receivers, one in the kitchen, one in the bedrooms. Of course, overall accuracy using the R2 or R3, which located in the kitchen and bedroom was lower. However, they were better in recognizing some of the activities. For example, the eating action was actually occurring in the dining room. However, the recognition was better when we use R2 receiver data. So when we somehow combine all those data, we were able to reach to the 99% accuracy in classifying those four. So which means that if we can better knowing that the effects of the housing environment on the performance of those Wi-Fi based ADR recognition system, then somehow there will be a way that we can address that issue. So here's the conclusion that, again, we found that in Korean homes, ADR recognition shows the lower performance. And then we are thinking that that is affected by the three factors: difference of the building material, the difference of the level of the Wi-Fi interference, and then maybe housing layouts. And then our future research would like to investigate the isolated effects of each of those housing environments on the performance of the Wi-Fi based ADR recognition. Thank you so much for your attention.
Thank you, Ryan. I think because we have exceeded the precision time, so probably we just invite one or two questions.
But I mean, the
other room.
Other rooms
okay.
are.
Yeah, you decide. Okay, any questions? I think, yeah.
I have a question about using multiple data sources. So you're focusing on Wi-Fi. Have you considered using smartphone devices and their link to Wi-Fi, or cameras in addition to the Wi-Fi?
Yeah. So what I mentioned here is that when we here using the receivers, I mean that we use laptops that we are able to collect the data in some way, but if it is developed as a practical applications, those Wi-Fi cell phones or the other Wi-Fi devices can be also works as those receivers. Yeah.
Claudia?
Yeah. Now I had a question about the training. The amount of data that you use to train the system to do the predictions. So, do you have an idea of if you increase the number of the amount of data, would you improve that, and if the different cases that you use, the Korea and the US, maybe react different, and maybe for the Korea case you need more data to train the.
Possibly. I mean, we use the same number of data for this case, so we just to make the comparison fair. But possibly, if we have more data and more training, there's a chance that we could address that effect of the housing environment difference. Right? So maybe more training will have the better accuracy.
I have a question. So have you considered the difference between if the home is one person and then the home is 2 person or 3 person, maybe the accuracy is different?
That's a very good question. Actually, it cannot differentiate the different users' behaviors. So far, the feasibility of this approach was proven for the one occupant. So our now scenario is that because we are targeting the elderly people, this is a part of this like international collaboration project with one university in Korea, Seoul National University, and then the overall project is providing the healthcare system for the elderly people who live alone at their home. So that is the reason why we are looking into this the performance of this system. But it is hard to differentiate. If there is more than one people, then there is a great challenge in the differentiating those behaviors. But I know that many guys in the computer science working on that, maybe they find a way.
Thank you. Okay. Any other questions? No?
I think it will work if you think about, we are not trying to monitor daily life of people. We want to check whether someone is alive or not. So I thought about the situation when all the doors are closed, and sometimes some people like to construction.
Mhm.
But still, you will have the irregular fluctuation if somebody is moving around anyway. So I think your method will work for emergency cases anyway.
I mean,
Viable solution.
so I mean, but the reason why the main motivation we are looking into this is not just about the emergent activities. It's more about we'd like to monitor the routine behaviors of the elderly people. So there is a great, I mean, well-supported theory that when the routines of the elderly people are starting to change, there is a great sign for their health status change. So, so we are more focusing on the typical activities, so sleeping, eating, and using the toilet and so on.
Thank you very much, Ryan. Hope you guys just enjoy your remaining days in New Zealand. Thanks. Very good discussion.
Yeah, good. Okay. Do you guys want to go to the other room? Yeah. So you only have 2 speakers.
Great delete.